My name is Lisa Kaufman, and I'm the Director of Programs for the Northwest Straits Foundation. We are a local nonprofit that works around the 7 counties of kind of the North Sound, working on marine resource issues, protection, conservation, and restoration. And the Shore Friendly program is part of that work, working with shoreline landowners. And Valerie is going to give us an overview of the program in a minute. But before we get started, why don't we just kind of do a little bit of housekeeping? For those of you that may not be as familiar with Zoom, since 95% of us are happier being outside and in the field, and rather than sitting at our computers, we'll ask you guys, since unfortunately we can't see your faces. At the bottom of your screen, there's a little hand. If you want to ask a question, go ahead and click on that. And then as the presenters are going through, they'll either try and answer them as we go along, or we will make sure we have time at the end of each segment to answer those questions. If you don't want to ask your question in person, you don't want to raise your hand, there's also the Q&A feature on the bottom of your screen too, and we ask that you would type it into that and not into the chat. If you're having any kind of technical difficulties, you can put a note in the chat, and we've got some folks that'll be monitoring that. But we want to keep this light. We know, again, that none of us want to be sitting here for 6 hours just staring at a computer. So we'll take some breaks as we go along, give you a chance to get up and stretch. And obviously we can't see if you're getting up and stretching, so do that as you need. But that's kind of the spiel I've got here. We'll have each presenter introduce themselves as we go through, and we'll see how we make this work. And again, we really appreciate your flexibility again, and just have a little bit of patience and grace for us too, because despite going through COVID and doing a bunch of webinars, we still kind of struggle with some of this technology sometimes too. So I'm going to turn it over. Oh, I guess before we do that, I have the agenda up on your screen at the moment. We'll flip around some of the topics here and there just for ease of presentation. But we'll give you kind of, like I said, a full overview of the Shore Friendly program, talk about vegetation and nearshore ecology within the shoreline, impacts of shoreline armor, functions and values of vegetation, shoreline hydrology. John Bornsworth will be kind of our primary speaker, talking about all things vegetation oriented. We'll have some discussions about permitting, cultural resources, and then we'll get back into John's talks, continuing on about managing vegetation and managing drainage. And then we'll talk about kind of contractor resources. You'll hear Valerie kind of talk about, the Shore Friendly program, but the reason we're really here and presenting this to you is because the contractors are really kind of the front line of work with our shoreline landowners. So we consider you to be kind of influencers in how they make decisions. And our goals are to have them kind of rethink how they interact with the shoreline in ways that think about habitat and species and functions in addition to their needs in protecting their own properties. So at this time, I will turn it over to Valerie Dos Santos with Island County, and we'll get going. So I'm going to stop sharing my screen, and there's going to be a lot of this back and forth of sharing screens and not sharing screens. So here we go. It's all you, Valerie.
Alrighty. Hey guys, just let me know if you guys can see that screen okay. Hey, just to introduce myself, my name is Valerie Dos Santos, and I am with Island County. I work under their Department of Natural Resources, but I'm their Shore Friendly coordinator. And a little bit about my background is I went to school for animal sciences and then recently got my master's in wildlife conservation and management. My background includes having coordinated and conducted environmental and biological assessments and surveys, mainly for threatened and endangered species. I've also done compliance monitoring, technical reports, and I've worked with federal entities all the way down to like nonprofit entities. And now I'm happy to be with Shore Friendly, the county. So a little overview about Shore Friendly is we have a ton of partners all throughout the Sound. On this slide, you see a couple of different examples of kind of what's behind Shore Friendly. So it is a federally funded incentive program for private landowners. Shore Friendly is funded through grants from the Department of Fish and Wildlife, mainly the Estuary and Salmon Restoration Program. as well as EPA funding that's, again, directed through WDFW. Okay, so our goals as a program, our program aims to cut down on shoreline armoring and revitalize shoreline habitats throughout the Sound to benefit fish, wildlife, and local communities. Shore Friendly is a regional program aimed at helping shoreline owners maintain natural shorelines, avoid hard armor, and explore alternatives. We use a lot of social marketing. So through social marketing, we build relationships and trust, making it easier for landowners to make informed changes by addressing their concerns. And we also try to provide the latest science via workshops, a lot like this one, site visits, and other ways that we interact with landowners just to help them make informed decisions about shoreline features like vegetation, drainage, and even at-home placement. Within the Puget Sound, about 70% of shorelines are actually in private hands, and 30% of them have already been modified. So our program really primarily just targets those private landowners. Okay, so for the shorelines within the Puget Sound features over 2,500 miles of shoreline, with approximately about 25% of it having hard armoring. This is a little concerning just because approximately 90% of our beach sediment comes from bluff erosion. So it's directly from the neighbor next door. Within Island County and Snohomish County, which these are just two pictures of the borders in which they have shoreline within the county regions. Island County itself has approximately around 200 miles of shoreline, making it home to the second highest percentage of shoreline parcels within the Puget Sound, while Snohomish County has about 130, much of which is already armored because of the BNSF railroad. Excuse me. So, hard armoring in Island County. So we recently actually just had a study done by our Marine Resources Committee, so our MRC, and they found that since 2016, approximately 95% of hard armoring that had been installed was actually done without permits. This is pretty concerning, especially since erosion rates within the Puget Sound mainly vary from moderate to low, and we can have a whole bunch of repercussions from having hard armoring. In Snohomish County, you can also see kind of here the armoring as well within the county. So that's what these reds are. These red lines are. So for consequences of hard armoring, shoreline armor can cause habitat fragmentation. It can cause loss of habitat connectivity, burial of the beach and forage fish spawning habitat. It can even be linked to reduced sediment input and impacts to littoral drift. So shoreline armor buries habitat and disrupts the connection between the marine waters and uplands. It is our goal through this program to help create resiliency. But our goal is to enhance climate resiliency and improve connectivity by removing the habitat fragmentation caused by past development, which prioritized views and separated the uplands from the marine environment. A fully functioning system is always much more effective than parts that have been isolated, and balancing shoreline protection with ecological health is crucial for sustainability throughout the Puget Sound. On this slide, you see two depictions done by an amazing person named Simone DeRoche. On the top, so this first image up here, you can see what the habitat should look like when it is all connected and flowing through correctly. And then on the bottom is just a representation of what the hard armoring actually does to the area. Okay, so to better understand the impacts the Shore Friendly program can have, we should first kind of review coastal processes and morphology of our region. So for starters, coastal processes is just a really fancy way of saying what causes sediment and things to move throughout the region. So forces like winds, waves, tides, currents, and storms all interact with the shoreline and nearshore seabed. So it includes the movement of sediment through erosion, transportation, and deposition. And it is the process that have helped shape our coastlines over time. Morphology just typically refers to the shapes and structures of coastlines and coastal landforms. And this includes the processes that shapes these features, again, such as erosion and deposition. With shore friendly, the most common ones we talk about are bluffs. So you can kind of see a bluff here. But this was all shaped and caused by glaciation, so glaciers. Our coasts were essentially carved out by glaciers around 13,000 to 15,000 years ago. And as glaciers deposited sediments and sea levels rose and they retreated, that's what created what we now know today as the Puget Sound. Again, our most common feature being bluffs. So bluffs are the most common feature along our shorelines, and bluffs by nature are an erosive formation that are vital for providing sediment to our beaches. Once again, bluffs attribute 90% of sediment in our region to our beaches. So they are what really supply our beach nourishment. Okay, and so what fuels our erosion in the Puget Sound? So erosion in the Puget Sound is influenced by both natural processes and human activities. These key factors include wave action and hydrodynamics. So our irregular coastline shaped by glacier activity creates complex wave patterns. These waves then hit steep beaches at an angle and play a really big role in moving sediment and causing erosion. And the strengths of these waves can vary because of limited fetch, which affects how quickly different parts of the shoreline will erode. For those of you who might not be familiar with the term fetch, this is just the distance over water that wind can blow without anything blocking it. This distance is important because it affects how big and strong the waves can get. So the longer the fetch typically means the bigger the waves. And in coastal areas, fetch impacts how sediment moves and how beaches erode and how the shoreline behaves overall. In the Puget Sound, differences in fetch can lead to variations in wave energy, which will then kind of influence how your beach will look. It also, a big factor is sediment supply. So erosion will actually worsen with the loss of natural sediment. Armoring along bluffs or with seawalls or bulkheads can actually hinder sediment flow, and this can actually increase erosion on downdrift beaches. Another big impact that we're currently facing is sea level rise. So as rising sea levels are expected, they are also expected to accelerate rates of erosion. And then finally, human modifications. So development along the shoreline often results in erosion control structures. And because these structures disrupt natural sediment transportation, the regulation of shoreline activities through those natural processes then itself is also disrupted. So having bulkhead construction and other things of that nature actually will affect the sediment and erosion within those areas long term. Any questions before I throw it back to Lisa to talk about some vegetation management or nearshore ecology? Oh, looks like I got one in the chat. No?
All right. Still kind of working through some of these little kinks here and trying to get the chat working and everything. But again, if you have questions, go ahead and raise your hand at the bottom of your screen. Yeah, so hopefully everybody can see the chat now. On the bottom of your screen, there's a little thing that says chat. So if you, we're going to use the Q&A again, just as a reminder, if you have, questions that you don't want to say in person. Otherwise you can raise your hand and we'll call on you. And actually, so we know people can kind of maybe see the chat and use the chat. Maybe everybody put in the chat, maybe where you're coming from and what you're, if you're an arborist or a landscaper or something else. So we kind of see that features are working. Probably should have done this earlier on. And in the meantime, I will share my screen as well. Let's see here. All right. You guys seeing just my presentation and not the notes and stuff, hopefully. Great. Okay. Well, Valerie, that was an awesome intro to kind of the basics of the shore-friendly program as well as our shorelines. John is going to be providing, a lot of that, most of the nuts and bolts about vegetation from the big picture, big umbrella kind of thing. But I'm just going to dive in just pretty quickly here about shoreline vegetation, specifically in the marine food web, and talk about some of the ecology of our shorelines, which I'm sure, we all kind of live in this area and recreate around here. So you're probably somewhat familiar with most of this. But generally, we kind of see our habitats and our species somewhat along this continuum. And their ability to survive and thrive really starts with healthy shorelines. We don't really think about orcas as really needing, shoreline habitat, but everything that they eat requires that nearshore environment, so that area right up along the shore at the high tides to be really healthy. Mostly because we have two species of fish here that we'll talk about a little bit more in detail that actually use our shorelines to spawn. So they lay their eggs in the sediments. Salmon, rely on those when they're small as well to eat them. And then orcas obviously are trying to eat those salmon. So if any piece of that puzzle gets interrupted or is missing, then the whole food web kind of unravel here. Obviously, that's a pretty generalized perspective on it, but I think we all get that idea. So you'll hear a lot more about the benefits of native riparian vegetation from John, as I said. But ultimately, in order for us to have that connectivity that Valerie was mentioning, we really need that vegetation on the nearshore, on our bluffs, on our low bank, on our medium bank habitats and ecosystems, because they really provide the basis of the nutrient cycling that all of these species require. I don't really need to talk about the rest of it. John will talk about, roots and stability and drainage and all of our hydrology, but just kind of sets the table here. So in a healthy marine nearshore, basically, we're looking at everything from starting down to the deepest of the water, below where sunlight will penetrate. The photic zone is the area where you can get sunlight penetrating. So we're kind of in this subtidal zone where we might have kelp if we have rocky habitats. We'll have kelp that's floating on the surface. We'll also have kelps that are actually kind of just hanging out sort of closer to the bottom. And you don't really see them up on the top. When you look at like bull kelp, if you're walking along a beach and you see those big tubes on the shoreline, those are typically from bull kelp or giant kelp. And that's important habitat for a lot of our species that are spawning within the water column. As you go a little bit further up into kind of the low tide terrace, that's where our eelgrass beds are seen and found. And eelgrass, is a plant that actually requires light. It's a flowering plant. We'll talk about it a little bit more in a second too. And then we start working our way into the actual beach zones itself, and then into the backshore. But what you're seeing commonly in every aspect of these ecosystems is vegetation. So that provides the connectivity, it provides stability, it provides nutrients, provides resources. All right, so kind of diving a little bit deeper into this. Kelp and eelgrass. They're incredibly important. Sorry, I'm trying to move my screen around there a bit. Kelp and eelgrass habitats provide features for salmon, rockfish, crab, many other species. Kelp in particular and eelgrass are where our herring are spawning. And they need this three-dimensional structure in order to spawn on it. But in the absence of kelp and eelgrass, they'll kind of spawn on other vertical structures, pilings, rocks, non-native vegetation that's been taking over. But the healthiest places or healthiest areas for them to spawn is within these eelgrass beds and kelp beds. I mentioned briefly already, eelgrass is a flowering plant. You can find it in kind of sandy, muddy areas around the low tide line. We have two different types of eelgrass in our regions now. One is a native eelgrass, and the other is a non-native eelgrass. There's a lot of debate over whether or not the non-native eelgrass is to be considered as an invasive species or not. But in our world, it's creating really good habitat. There used to be even just like 10 or 15 years ago, there was a distinct literal line in the sand as to where these two species would be. Our native eelgrass, referred to as Zostera marina, would be in the lower intertidal, and the non-native or Japonica eelgrass would be found really higher up on the intertidal. But now they're kind of they're growing basically in between each other. You can see them all over the place, and it's sometimes hard to differentiate between them. So again, there's sort of some debate over to whether or not we need to be concerned about Zoster marina. And in an absence of other eelgrass, maybe it's okay that we have this other one, and we have this non-native one coming in. Kelp is a general term for a type of brown marine algae. The kelp in this particular image that you see floating around with the kayakers is bull kelp. We have volunteers all around the Sound that have been doing surveys to document the health of our kelp beds. Because there have been significant declines throughout the region of kelp and algae. And some of those, when you're talking about kind of with your clients, the things that are happening on the uplands can have direct influences on our kelp and our eelgrass beds. If you have friends that are, or clients that are fertilizing within the nearshore area, like if they have lawns that are really close to the shoreline, fertilizers that are used on land will also end up eventually fertilizing plants in the water, and not necessarily to a positive effect. We have an increasing amount of ulva, which is a green leafy algae that just is a kind of a floating algae. You'll find that all around the Sound, but it can indicate eutrophication, which is basically kind of ends up like a loss of oxygen really in the water column, and it can end up kind of killing off a lot of other habitats because it really smothers them. Generally, seafood or eelgrass, not so much eelgrass, but kelps are used for food. It's used commercially. It's used in a lot in beauty products. So, how it gets harvested also needs to be managed so that we don't overuse the resource. All right, that's not going. Come on. Nice slide. Of course, is not advancing. Hang on a second. There we go. Okay, so when nearshore habitat is degraded, it makes it much more difficult for fish to survive and return to spawn. There's a marine survival project that's been going on for several years, kind of looking at what's happening with salmon once they leave the rivers. And it's showing that fish are surviving once they hatch, in many cases, to make it out to Puget Sound, but they're not surviving in high enough numbers when they're in the marine environment to return to spawn, which is driving a huge reduction in the population. Salmonids require shade, healthy vegetated nearshore habitat. Until they're large enough to consume smaller fish, most of the diet of juvenile Chinook salmon in particular comes from insects that are falling out of marine vegetation, as well as those invertebrates that are found in the beach wrack, which is kind of that line of grass and sticks and detritus that ends up rolling up with each high tide. All right. See the different types of salmon. Actually, these are just, different stages of our Chinook salmon. They kind of start out, having lots of little parr marks on them, which are those stripes that go through the midline of their body. As they start getting bigger, those parr marks start to fade until they're a healthy adult salmon, when they're pretty much, what we think of as a salmon as being a nice silvery fish. What you can see also on the screen, we're looking at kind of the food source, is an example of a larval smelt. So it's a small fish, again, that also does spawn on our beaches. And that's kind of what they're eating when they're coming out of the rivers and they're hugging the shorelines. Along with that, like I said, those insects that are coming out of the marine or the riparian vegetation. Come on. There's like a lag in my screens moving forward for some reason. Here we go. Salmon in the Whidbey Basin, which really includes, the interior of Whidbey Island, Camino Island, and the shorelines of Snohomish County, are incredibly important for salmon production. We have, them coming out of the Skagit. These are big river systems for this area. So a lot of the fish that are found throughout Puget Sound are coming from these 3 big river deltas. Which kind of just gives you an idea. And they're really utilizing the entire area. A fish coming out of the Skagit as a juvenile is going to be utilizing the near shores of this entire area before it finds its way back out into the bigger ocean waters. And they spend quite a bit of time, especially Chinook in particular, spend most of their life cycle actually just, or the first year of their life really hanging out within the nearshore area, hugging the shoreline, finding little pockets, pocket beaches and pocket estuaries, areas where they can hang out and grow big before they go out to the Pacific Ocean. And what they're relying on, and as they're growing, as I said, they're initially their first food source is going to be insects, but as they get bigger, they're going to be relying on a category of fish we refer to as forage fish, which is really basically anything that is smaller than the fish that is trying to eat it, or the other critter that's trying to eat it as well. I mentioned already, we have two species of fish that are particularly critical to our fish around here in the Sound. Surf smelt and Pacific sand lance are beach spawners. So they actually utilize the sands and gravels within the high tide to mid tide areas, lay their eggs. A couple tidal cycles later, those eggs will hatch, and then they'll be kind of floating out in the water and hopefully being able to grow into healthier fish. Pacific sand lance are really a curious fish too. They tend to spawn lower in the intertidal in those sandy habitats. But they also have these weird burrowing features where they're actually going to like dig their heads and their tails into the sand. They're found also in really deep water mounds. So there's a lot of information that's trying to be learned about Pacific sand lance, because it turns out that Chinook salmon in particular are reliant on Pacific sand lance more so than surf smelt even. But our marine birds and all of our, a lot of our other critters that are, hanging out in the Sound all rely on these categories of fish that, again, we collectively refer to as forage fish. Herring in particular is also considered to be one of our key forage fish species. They're spawning, as I said earlier, in our marine waters, utilizing eelgrass and kelp beds as well. The map that you can kind of see on the right-hand side just sort of shows you an overview of where the spawning has been detected. A lot of these maps are outdated, and we've got volunteers really all around the Sound that are trying to update this information and get out to our beaches and figure out where it is that the spawning is occurring, because this is actually included as a regulatory feature in what people can or can't do on their beaches. If they wanted to build a dock, if they wanted to put in a bulkhead, which we're hoping to avoid, knowing whether or not there are spawning areas or even just potential for spawning can dictate what somebody can do and when they can do it as well. So a little bit more here about our surf smelt and our sand lance and herring. Again, this kind of just shows you the tidal ranges and the nearshore zones where they're spawning. And if you're ever walking around on a beach around Puget Sound during a spawning event, it looks like tiny little specks. So it's just, they adhere to grains of sand and gravel, tiny little round eggs. So if it looks like a piece of sand is a little bit too round, it may actually be an egg. And they're pretty hardy. You can't really damage them by walking around on the beach, but certainly if you put an excavator in the sediment, you can definitely destroy an entire population of forage fish that are trying to spawn in that area. Right, and typically, historically, the surf smelt in particular would spawn year-round throughout most of the regions of Puget Sound. Sand lance are typically more of a fall into a winter spawners, and herring, it depends really where you are in the Sound. Up here in the North Sound, particularly there's a Cherry Point stock that is an early spring spawn, and then it kind of, again, it varies depending on where you are in the Sound. The herring populations are also in South Sound, in some areas they may be doing fine. In Cherry Point, up here in the North Sound, where we're located, up outside of Bellingham, this is a stock that has been crashing significantly for many years now. All right. So when you're walking around a Puget Sound beach, or you're working with your clients throughout the Sound, a Puget Sound beach should be messy. Large wood should accumulate on beaches from falling trees, as well as being transported around the Sound through wind waves and storms. And large woody debris on the beaches creates vertical and horizontal structure and habitat. It creates anchor points under the sediment as well for roots to attach to. There's been a couple studies a few decades ago or so where somebody actually kind of dug underneath a lot of the sediment on the beach, and they actually just found logs and logs and logs that were actually, feet below the sediment line. And attached to that are the roots of the dune grass and the vegetation that's been growing in that upper nearshore area. So riparian vegetation, contributes to the food web, as I said already, through insect fallout. Also just the detritus, so the sticks and leaves and everything that fall from those trees onto the shoreline and contribute to that rack line. Also provide habitat for invertebrates. So those beach hoppers, sand fleas, those things that when you pull up a wad of eelgrass that's laying on the beach, and you have a whole bunch of bugs kind of jumping out at you. Those are insects and invertebrates that are only found in that area. So they are reliant on that beach rack. They're not marine derived. They're not related to, they don't survive in the upland habitat. So having this detritus, this material falling from the trees and shrubs, as well as that eelgrass rolling up and kind of combining it all together, is also providing habitat for these species they're really rich, they're fatty, and so they provide a lot of nutrients as well for our species that are swimming along the nearshore at vulnerable stages of their lives and trying to grow. You can kind of see different habitats here. Historically, when we've been logging all of our uplands quite a bit. So there's actually now probably an unnatural amount of wood that's accumulating on our beaches, but it doesn't have these large root wads anymore that you would get from trees falling from the shoreline onto the beach, providing that structure. So a lot of the wood on our shorelines now is quite a bit more mobile. But if you have, you're always going to, for those of you that are arborists and landscapers, you're going to get those questions from landowners about tree safety and whether you should leave trees and what you should do. And John will talk quite a bit more about this, but what we would hope you would do, that if a tree is going to be, falling, or if you're going to, if you have to take it down, let it fall on the beach itself, because it provides that habitat, structure, and functions that's necessary. Right, and these ecosystem processes that Valerie was talking about, as well as accumulation of large wood and vegetation, also affects our nearshore birds. Marine and shore birds also rely on intact coastal processes. They forage in the nearshore, in the mud, in the sand flats, in between the logs, and they also use it as refuge too. Even the poor misunderstood glaucous-winged gull that you normally find, eating French fries. If the French fry supply isn't around, they certainly prefer to eat food that they're finding in their beach rack and in our vegetation as well. All right. So that is it for me. If anybody has any questions.
Lisa, we have one question in the chat.
Okay, 1 second. Stop sharing. It's in the chat.
Yeah, I can read it if you'd like.
Yeah, that'd be probably good.
Yeah, it says, what is the effect of human harvesting on salmon, and how is the effect differentiated from loss of habitat?
Wow, that's a pretty complex deep question.
Yeah.
When we talk about salmon recovery, it really is sort of a multi-pronged thing. It's habitat, it's harvest, it's also hydro power, dams, that kind of a thing, as well as there's a lot of pieces to the puzzle. Loss of habitat at this point is probably the greatest impact. Harvesting and fishing it's a lot more manageable in the sense that the Department of Fish and Wildlife and the other agencies can regulate how much fish is being taken out of the sound. But definitely, unless we actually recover the habitat, we're not going to have the ability to have that recovery happen. So it's a complicated web. It's all sort of connected. It's like, Austin, do you have a question? You can go ahead and just say it since you can talk.
Yeah, my question. So a lot of times when we're talking to owners about like the impacts of armor or removal of vegetation, we try to stress that, it potentially affects like forage fish. And my question would be about Cherry Point specifically. It's something that we're aware of at the county, and we've talked about at least internally with our other planners. And I'm just curious if there's any understanding of why the populations are crashing up there.
I haven't really followed it in probably about 10 years or so. There was, a ton of different, possibilities, everything from overdevelopment of the shoreline, to, changing water temperatures, to the impacts potentially from the Cherry Point industries, increasing numbers of large vessels, and whether or not, there was a change in the vegetation structure. I know that there's definitely been a change from, having a lot of kelp and eelgrass to more non-native, marine vegetation. I'm not sure that they've ever really put their finger on the pulse of exactly what the problem is, though.
Thank you.
Yeah, sorry. It's kind of a
It's all
non-answer.
good. Yeah, I appreciate the info.
Yeah. All right.
It looks like we have one more question. John might be typing an answer, but if you wanted to take a crack at it, it says, we worked on a project with a dead tree at the toe of a slope that had been failed over the years. Oh, it just missed. There it goes. We felled the tree parallel to the slope, and the property owner used a cable to anchor it loosely to a couple of stumps. Was this a good practice or best to leave the tree to uproot? Well,
Might be, it depends, kind of question. I would not suggest that any general landowner or, individual ever tries to attach a tree or a log or anything to another structure, be it another, tree or log. Mostly because, within our tidal systems, logs are going to be bouncing around within, as they float in and out. And you want to be able to have it kind of find its own place. Otherwise, they become a battering ram. It can actually exacerbate erosion. But if you can get that root wad to be on the actual shoreline, then that's probably the best thing, because over a couple tidal cycles, those roots will eventually kind of work their way into the sand, into the sediment, and provide stability and habitat there. And then it actually ends up you can have, dune grass that builds up in the sediment behind it, which adds increasing levels of protection as well. Did I answer that correctly? Did I hit the mark on what they're asking?
yeah, and John also says he's gonna discuss this later, so.
Awesome. All right. I can't see my agenda anymore. Okay, so I think I am passing it on to, I can't close out. In the show, there we go. That's right, just getting back here. Okay, I guess I'm passing it on to John now to actually talk about those functions and values of shoreline vegetation.
Hey everybody, we just have a minute here. How does that look?
Looking great.
Perfect. Well, thank you all for coming out today. I'm really sad that we can't see each other in person. Can't see all your wonderful faces. But nonetheless, thank you for attending the virtual version. So I'm John Bornsworth. I own Peninsula Environmental. We're a consultant and general contractor based out of Port Angeles, but primarily work in the Puget Sound metropolis. I've been a consultant for about a little over 10 years. I'm a board certified master arborist and registered consulting arborist, tree risk assessment qualified. Also a CECL, certified erosion control specialist, lead, forget the name. Really interesting certification by Department of Ecology. Yeah, my firm works in a kind of a multitude of different frameworks. We work in environmental regulation, so shoreline regulation, and also wetland regulation. So it's nice to have that kind of multifaceted approach to these areas. I specifically look at trees most often, but as we know, these areas are highly regulated and also very sensitive. So it's good to have that, that experience spanning those things. All right, so my first presentation today is just going over the functions and values of shoreline vegetation. We've already discussed a little bit of the functions and values of just shorelines themselves, coastal processes, but this is going to focus more on the vegetation, on the trees. Valerie already kind of talked about this, but when we talk about functions, what we're really looking at is the processes, the natural processes that trees and plants provide. Things like stabilizing shorelines, filtering pollutants, the nutrient supply, climate regulation, biodiversity, all of those functions that you know, these trees and plants are providing. Functions are scalable. So a single tree may provide, you know, habitat for a wood duck, but many trees provide, you know, habitat connectivity. And they are somewhat site specific. While you may have a function providing a service at one site, it may not be providing an equal service at a separate site. Our values, on the other hand, really speak to the importance we put on those functions. And that's also variable depending on the scale of who's valuing that, right? You might have a community value shorelines for recreation, for habitat, economic, aesthetic, things like that. Recreation, of course, fishing. But then on an individual homeowner scale, you know, their values may be things like property values, views, lawns, also maybe eagles and orca that they can see from their house, you know. These values and these functions and values, they do overlap a little bit, but they are specific concepts, right? So if we are, you know, a value of trees is climate regulation, but trees provide climate regulation functions like shading and wind attenuation. So they're separate elements. Here's just a list of some of the values and functions that we have. I kind of talked about a lot about them, but I think it is interesting to point out the fact that, you know, the community may value these shorelines in one way, when then homeowners may value them in different ways. And we'll talk about that later on with erosion as well and mass wasting. A couple of just quick definitions. I think most of you probably know this, but I'll just cover this quickly. You know, groundwater, that's our water that's in our soil, held by soil pores. Stormwater is our precipitation or the rainwater that is intercepted or hit by hardened surfaces like roofs or asphalt parking lots, and then usually runs off of that surface. Rainwater precipitation. Our marine water is you know, obviously our salt water that's interacting with our site. Our flood water is abnormally elevated marine waters or abnormally elevated stormwater. And then the OHWM, you know, this is a pretty common term in shoreline management, the ordinary high water mark. That's a biological vegetation mark on the beach that indicates kind of an average tide height or an average tide elevation. So we're going to split up into two different kind of sections here. We have a hydraulic section and a mechanical section. Our hydraulic section of, well, some of our hydraulic functions include our rainfall interception, transpiration, evapotranspiration, infiltration, you know, these things that trees modify hydraulic conditions on sites. I'm going to talk more about this later. This is just kind of a summary. Here we have our mechanical functions. That's our roots interacting with soils. We have fine roots, create a mesh network usually on the surface and slow down erosion. And our structural roots, our larger roots, increase shear strength in slopes, also surface roughening and distribution of loads. So here's some of our hydraulic functions. I think most of us know this, but you know, when you're walking in a forest under a storm, during a storm, the trees intercept your rainfall, right? We have evergreen trees can typically intercept 40%, 20 to 40% of rainfall that hits them, and then kind of slow down how that rain hits the ground. So the rain isn't just hitting the ground all at once and creating stormwater. Transpiration, evapotranspiration. This is the wickening, the soil wickening of trees. How water is taken up by roots and transpirated into the air through our leaves and through our respiration of trees. Again, rainwater interception. It's important to just remember that evergreen trees provide most of our rainwater interception. They provide that year round. Obviously, our deciduous trees are not providing that function in the winter. There is some interception that a dense colony of willow or dogwood may provide without leaves, and of course, our big leaf maples have a lot of epiphytes, moss and lichen and whatnot growing on them, which absorb some water, but the vast majority of that rainwater is held by evergreen plants. So some soil functions. When trees and plants respirate and when they're basically moving water, of course, from the roots up to up to their leaves and releasing that water. So they're they're just removing water from the soils. Detritus and mulch, as our leaves fall, and you can see the picture on the right, a nice forest full of mulch. The detritus, that's just containing our rainwater and buffering it before it goes into the soil. If your soil cannot infiltrate that much water, the mulch will slow that down. And also soil cohesion is an important part. That's basically the stickiness that soil has when it's dry compared to when it's wet. Another interesting picture here, this is a photograph from Dr. Bob Edmonds at University of Washington. This is a 26-year-old hemlock stand in Clallam Bay. And he was doing studies on it back in the 60s, where he was injecting herbicide into the trees. I think it was a bark lance, actually. But it was killing surrounding trees. And he wasn't exactly sure why, injecting one tree was killing the nearby trees. And then a decade later, another student came out and power washed, hydro-excavated the entire site and just identified that all of these roots of these hemlocks were intertwined, connected with one another, grafted. And some of them were still alive. So since they're obviously not producing new branches or producing new leaves, but that root wood was still alive, connected to other nearby trees that had not been culled or cut down. So that kind of just goes into how roots really interact and stabilize soils. Which leads me to this. So the science behind root reinforcement, the mechanical stabilization of trees on slopes is wild. So we have 30% to 234% shear strength increase. It's highly variable based on obviously grade of your slope, hydrology, and composition of soil, right? Is it sand? Is it glacial till? There's just a wide range. I kind of put this in here is just to highlight the fact that some of these things we can't know. This is very site specific, and we're not going to understand the actual percentage of shear strength increase by trees, but they are providing a vast quantity of shear strength increase on slopes. And in case I guess I'm using that term a lot, shear strength is basically if you have a slope like this, the friction that goes back and forth between two layers of soil, if the roots can grow between those two different layers of soil, that's increased shear strength. What we commonly see on trees on slopes is both lateral, so sideways, and then anchoring support, so inward to the slope. You can see here on this tree, it's basically, this is a Doug fir and kind of down in Centralia, I think it was. Not on a shoreline slope, but nonetheless, it's basically forming a retaining wall with these lateral roots. And then on the bottom of this tree, you can't really see that too well, there's one main root just going straight down. So we have these interior to the slope roots, and then straight down anchoring support. This is probably well known, but of course, you know what I learned was the tree of life sort of thing on the right is not accurate, and most of our trees in typical conditions are going to be in the, can you see that? Going to be in the surface of our soil horizon. You know, the analogy is a dinner plate with wine glass on top. But what if we have no soil? Can you see this mouse? You know, what if we have no soil on this side of the tree root? There's no soil there. Trees aren't going to just fall over necessarily. They're going to adapt and typically grow downward. You know, tree roots are opportunistic, and they grow where conditions are favorable, and also grow in areas where they will, you know, keep the tree supported and upright. Here are two photos just kind of showing that. The one on the left is this is further out east, but it's a conifer. You know, you can see where they have these lateral roots going into the slope, and then because there's not much soil on the other side, there's a deeper root going downward. Doug fir on the right, again, these giant lateral roots going sideways, kind of holding up that soil. Here's a tree. This is a photo from Jesse Brighton in Oak Harbor. But this was a landslide in this is the Noble Cliff landslide, I believe. Austin may know about that. And I'll talk about this a little bit later too. But you can see this Doug fir, these roots are deep. And I think that it's important to realize that our idea that tree roots never get deep in our typical environments, I think it's important to just consider that on very sandy slopes, in these shoreline environments, we can see very deeply rooted trees that are securing soils on sites fairly well. Maybe not well enough on this site. Our surface roughening. This is really just kind of considering the idea of surface runoff and how quick that surface runoff is progressing down your slope. The velocity of your runoff. If you have a runoff with a very high velocity, you're going to see erosion, rills forming in the soil, which we'll have a couple of photographs later. But it's basically channelized water that's running on the surface, but also channelizing into little pre-streams. Surface roughening like mulch, natural mulch, detritus, and also our just regular wood chips, grass, native vegetation, ground cover, things like that just slow down the velocity of our stormwater, reducing erosion. So just a quick discussion about some other functions of plants on shorelines, not related to slope stability. Wildlife, of course, trees provide a significant amount of avian wildlife habitat, both foraging and perching in the Puget Sound. We'll discuss a little bit more about habitat trees later on, but generally speaking, you know, if we can retain a tree in a shoreline environment without risking its without risking a failure onto a structure or something like that, or causing a landslide. It's worth thinking about retaining that tree and protecting that habitat. Lisa talked about this a lot, but beach rack. This is really an essential part of the food web. We have, there is a push I see for some homeowners to think, let's clean off our beaches. These bugs are not. I don't want to walk on the beach and have invertebrates jump on me or insects jump on me. Well, that really degrades the shoreline environment. And I have seen landscapers and some other firms clean up the beach, remove dead wood, remove all this material. It's not something we want to do, and this is like a critical part of the marine food web. Equally dead and living and dead riparian vegetation, coarse and fine wood, or large woody debris, coarse woody debris, and fine material is all useful. The mangrove analogy is not exact. We don't have mangroves here, but the idea is that if we leave this material on beaches, our waves, the wave action, the wave energy will be reduced when it touches our slopes. This was a project in, I believe this was Paulsbo, where the homeowner wanted to remove, there's a couple trees that fallen, and he wanted to clean this, clean it all up and remove all this wood, cut up into firewood or whatnot, and just do what people do, and that's, manage things. And my recommendation here was just to leave it all. This is great, both habitat and energy reduction, wave energy reduction on your slope. Equally, I'd like to just remind people not to forget up the hardwoods. Red alders, cottonwoods, things like that are very important to our marine ecosystems. That nutrient pulse they provide every fall. Evergreen trees drop needles throughout the year. There's never really a significant amount of them, but the detrital outfall of all of these leaves dropping all at once, rapidly decaying leaves, and then alder as a nitrogen fixing plant. The nitrogen fixed in alder is not really in the soil, it's in the wood and the leaves. As it drops those leaves, decays, and then it's at that point sequestered by the soil. Some tree services don't like this idea, but sometimes when I have a red alder that's being removed, I commonly recommend planting a new red alder. And I understand that will have to come out in 30 or 40 more years, or 20. But we want to not just convert all of our all of our deciduous trees into coniferous trees. This is just a short little thing. I'm kind of running out of time. This is my last slide. On the right, we have a very minor bulkhead. This is like 6 inches, a little seawall, and this center line, where the stakes are, that is our ordinary high watermark delineation. There was kind of where the boat was. There was maybe 4 feet, 4 feet beyond the ordinary high watermark and their lawn. When they had floodwaters, their crawl space was full of water every time. The side on the left had about 75 feet between the ordinary high watermark and their lawn. So when the side on the left received excessive floodwaters, that seagrass, the beach grass, and that wood, the wood slows down the velocity of the floodwaters. The beach grass allows for infiltration with its roots. And that sandy soil can absorb all that water or infiltrate it. And the homeowner on the left did not see water in their crawl space. So just the importance of maintaining riparian vegetation, marine riparian vegetation in these shoreline environments. So just a quick recap, shoreline vegetation plays a crucial role in Puget Sound. Mature evergreen trees really provide the most hydraulic function on steep slopes and mechanical function, but deciduous trees play an essential role in wildlife, nutrient cycling, and soil chemistry. And one thing that I always promote is just remove only what is necessary based on risk and maybe some aesthetics, but really focus on removing only what is necessary for whatever it is you're trying to do. All right, that's my last slide. Was there any questions?
I don't see any questions in the chat just yet. Or should I say the Q&A? So if anybody has questions, you can put them in the Q&A, or you could raise your hand. Okay, well, we can move on to hydrology then.
Perfect.
You're doing great on time, John, too. We're kind of ahead of time.
Okay, perfect. Let me redo that screen share. Okay, can you see that?
Yes.
All right, so we're gonna talk a little bit about shoreline hydrology. So this is the photograph of our just our natural, typical living, breathing forest. This was on a slope in Hansville, I believe. I really like to think of our forest as living and really breathing. Breathing is one of those it's one of those processes that we see in soils and plants. Forest soils are alive. They're constantly processing, breathing, regulating moisture, regulating temperature. As I mentioned earlier, that detritus is so important in just reducing the intensity of infiltration in soil and just elongating that time it takes for water that hits the surface of your forest or surface of your site to infiltrate into the soils. A lot of our microbial activity and root growth maintains this soil porosity. So when we talk about infiltration a lot, and really what is infiltration? What we're talking about is pores that are opened in soil due to root growth, microbial growth, and then equally or microbial activity, and then further root death and root decay and further microbial activity, creating pockets and voids in our soil. Many trees and plants we have our fine roots, we have our structural roots. We typically know that fine roots are the ones that are absorbing nutrients, transporting water. Our structural roots are the ones that are holding the tree up. Usually those are kind of in the 2 millimeter range. A fine root is less than 2 millimeters, and above that, maybe a structural root. Equally, our fine roots are, many of them are ephemeral. Some of them are perennial. Ephemeral fine roots may last for 1 or 2 seasons or less. And then they're gone. They're really kind of they're seeking out new areas to potentially, they're seeking out new areas of water and nutrients. It's interesting, these ephemeral fine roots of trees can be the majority of a tree's net primary carbon production. So it's somewhere between, I think, 30 and 60% of a tree's carbon production is just based in these ephemeral roots, seeking out new soil. And those ephemeral roots then dying and opening up soil pores. I'm sure we know about mycorrhizae, but the idea here, mycorrhizae is interesting. If a tree root, a fine tree root, so like these less than 2 millimeter tree roots, was the size of a 3-inch fire hose, a mycorrhizae would be the size of a human hair. So very, very small. Well, the hyphae of mycorrhizae, so the kind of like the roots of the mycorrhizae, the fungus. So these kind of coupled together, these things just navigate through soil and open areas up. This is a typical composition of a forest. The organic and the mineral can vary significantly depending on where you're at. The air and the water can also vary significantly depending on where you're at. But generally, we're looking at 40 to 60% material, and then the other half is a pocket, is a void in the soil that contains water when it's wet, or partially saturated or fully saturated, and contains air the rest of the time. So trying to manage time here because I had a question and answer thing kind of midway through this, and want to make sure I don't have so much time for that. So here's our.
You still have plenty of time. We're ahead of schedule
Right.
here.
So here's kind of what we're talking about here. Our precipitation intercepted by canopies, evapotranspiration. We already talked about this. So we have all these functions, have all this hydraulic management on site. Rainfall is being managed. Stormwater, if it's generated, is being managed. Infiltration is being managed on a natural site. That typical living, breathing forest. That's before, and then what do? We come in and cut down the trees, clear the vegetation, remove the topsoil, compact the remaining soil, and completely, completely modify everything. In our framework of building homes and getting that development or that action through. So obviously, before and after, we're not supporting the same systems or the same processes as we were. This is a site this is in Whidbey Island, but it's just a good example of on the right here we have our we have a generally natural forest. We have our interception, transpiration. We have typically porous soils and less views. And on the other site, the more developed site, is cleared, graded, compacted, non-porous, but there's a lot of views and some lawn. We expect that on the natural side, we're going to have 10% is kind of large, but less than 10% is typical natural forest runoff. So water that hits the ground in the forest underneath the trees and runs off into the beach and the water. On the other side, we may have up to 40% runoff. One thing I like to point out is that these developments, a lot of times people think about, can we just build the same development while retaining more trees? And a little bit, potentially, I think that's a possibility, but I think retaining, if anyone's been in shoreline development work as an arborist, we know that retaining trees costs a lot more. If we have to have an excavator operator, machine operator, is typically just going in hard and fast, working very efficiently, and not worrying about impacts to natural vegetation or trees. Once you start having them look for those, that's just more time. So it is possible. I think that there's a lot of techniques, and we'll get into those in the tree care side, but it's just something to think about. So in these areas, we have our these saturated soils. This was a slope. The slope is just further in the photograph. Lawns are generally non-porous. Department of Ecology in the wetland rating and also in the stormwater management manual of Ecology's, they're both rating lawn as 50% impervious or 50% pervious. So if your roof is 100% impervious, lawn is 50% of that. You can imagine if a homeowner is able to aerate their lawn well and dethatch and maintain their lawn, then you do get more soil water infiltration into that. But I think that's pretty rare. Most homeowners mow and that's it. So in those areas, you develop a really thick patch of thatch, but then beneath that, a thick, dense layer of roots that are not very deep, and water doesn't go anywhere. So this does increase when we get to these saturated soils. They're heavier, they're less cohesive, so again, less sticky. They can't stick to each other, and they're more prone to failure. There's our compaction. So before we had our 50% airspace and 50% material, and now we have, very little airspace and very little and less availability to hold water. All right, so one question that I commonly get is, well, if we are building a house in this pocket of this a parcel, maybe 10,000 square feet between the driveway and the compacted soils, well, why can't we just but there's still retained vegetation maybe on their side yards or their backyard or front yard. Why can't we take that stormwater that's now generated by our development and put that into those soils surrounding us? And that's not a good idea generally. The reason being is that after development, oh, I skipped a key point. Sorry, this Zoom is a little more difficult than in person. A key point here is that once we do all this compaction, once we have this compaction, there's just less place to hold rain. There's no place to hold water in the soil. So should we direct it into the nearby soils around the house? And generally speaking, that's no. And what we're doing in that, if we did direct stormwater into these native soils that are surrounding the home, we never went in and increased the infiltration capacity of those surrounding soils. We didn't manage the infiltration of those areas. So by then adding more water, more saturation to those existing native soils, we're then just we're creating saturation excess. So when we have saturation excess runoff is basically when you have saturation is 100% in your soil. There's no more pore space available to hold water, and you generate runoff. That's not something that we want to have on our shoreline slopes. And that's not always 100%. Depending on soil texture, it's possible that we may have enough infiltration in nearby native soils, but we're not going to get to the point where we're measuring that soil density and measuring that infiltration rate. So typically we're going to just move that water somewhere else and let it infiltrate, typically on the beach. All right, I think that was most of what I wanted to talk about. So recap is just that development significantly alters the hydrologic regime, and our ecosystem services provided by trees that we talked about last slide or last presentation. And nearby soils cannot take the place of our nearby compacted soil and don't oversaturate our native soils. We will mention decompaction in the tree care one a little bit, but generally speaking, fixing soil compaction is a difficult process. It's not the most easy thing. So just don't decompact if you can. All right, that was that. So we have a couple of questions.
Do you see those in the chat box or do you need me to read them? Or
Yeah.
the Q&A? Okay.
So what did more plastic mean on the soil slide? The plasticity of soil is, how do I say it? It's basically how much soil can bend without breaking. So if soil is kind of, you know, if it has a higher friction, it can move or bend or just kind of be manipulated without losing its shear strength and failing. But once it loses that, you know, when it's wet, when soil becomes really saturated, it loses that stickiness. And then if there is like some manipulation, then there's less resistance for it to kind of stay where it is. That's my general understanding of soil plasticity. And Tristan, yeah, I will talk about vertical mulching and radial mulching a little bit and provide some techniques. And I could talk about that in just a second. I see that a lot, Tristan. I see so commonly, at least in some areas, they'll harvest the topsoil, stockpile it, and put it back as topsoil in your post-development setting. I think that's what you're asking, right? Storing the
Yeah,
Yeah.
that's right.
Yeah. So I think that's a good good technique. I only see it in places where there's significant levels of regulation because it's an expensive process and nobody's going to do it. I don't think most people do it generally. I think there is issues with, if we're just using a machine to rip up that soil and stockpile it in a large stockpile, there could be issues with compaction. And then you're just putting back, while it might be organic and natural, you might have resulting compaction due to that stockpiling. Rainfall, snowfall, whatnot on the stockpile if that's a situation. So I think it has benefits. That's about it. So Mac Klein mentioned that he sees a lot of design similarities with low impact development, LID practices, and shoreline restoration. And does the Washington Stormwater Center ever have involvement in shoreline restoration like this? Lisa, do you know? I don't know what the Washington Stormwater Center is, so I can't answer that exactly. But I think it is very connected, right?
I believe, I think the Washington Stormwater Center is affiliated with, I think it's UW-Tacoma, maybe, where they've been doing a lot of the studies on stormwater, like the chemistry of stormwater and looking at different opportunities for like different mulching and soil types. But I haven't really been following it. And most of it, to my knowledge, has been related more towards like stormwater coming off of major highways, and trying to kind of figure out what those chemical soups are and if there's ways to abate some of that. So I'm not really sure that if they've gotten directly involved with shoreline restoration in particular. Not a bad idea to look into that though. Yeah, they were definitely I think some of the folks that were kind of looking at differences, in like what it is that it's, killing salmon when they're coming back upstream and trying to figure out, what is that like. Yeah, I think it's off of like the 405 highway in particular or something like that, where they were just, finding all these just nasty mixes of chemicals that interact with each other when they, as they're in the runoff. But yeah, I'm not 100% clear on it.
Yeah, and I think that, LID principles, now I'm looking at the camera, LID principles really are highly applicable in shoreline environments. We're trying to reduce runoff. It's just an increase infiltration, retain infiltration post-development. but I think the difference is we're just looking at different, you know, in LID management, we're looking at urban centers that are highly polluted and trying to reduce pollutant risk, while in shorelines, we're doing managing other types of risk.
Yeah, I think just to add in here, John, too, sorry. I know the Stormwater Center may also have been kind of the group that was looking at rain gardens, and you know, a handful of years ago, you know, there's still a big, you know, push towards putting in rain gardens in urban areas. But they were determining too that the type of soils was actually more important than the type of vegetation that was being placed in these rain gardens. So you know, that's some of the work they're doing too. But yeah, again, we can look into it more and get some information. Just kind of throwing a question out maybe to the participants. We've got, you know, we're definitely rolling ahead of time here, which is great. Just kind of wondering if, you know, those of you that are working in the shorelines, if you're still seeing a really big push from landowners to install lawns, and not as big of a push for people to, you know, put in native vegetation. I know a lot of, you know, in new development now, I know a lot of the regulations require, you know, a certain percentage of native vegetation to be planted, but I'm just kind of curious, throwing it out to the group here, what you're seeing in your interactions with landowners. Again, feel free to, you know, you can either raise your hands or even answer in the chat if you wanted to. It's not required, then folks prefer lawns, huh? Yep.
Yeah.
Yep. Go ahead. Figure out. Hang on a second. I gotta get around to figuring how to. I got too many things going on at one time. Trying to get to you, Kathy. There you go, Kathy. You can just go ahead and unmute.
Oh, on your question about what homeowners are doing, I've noticed in what I do that there's not really a connection with the soils and the plants. It's like one or the other. So if it's like a focus on, native plants and all of that, but then the soil as like a structure, doesn't really come into part of it. So a lot of the classes that I do are about like assessing your soil by actually bringing samples and looking at it and having people bring things so that they can understand the connection between how the plant's roots get into the soil. So I probably noticed that a lot because, you know, I have a lot of people interested in that.
Interesting. John, anything to add to that? That one, John?
Not necessarily.
So my name is Austin Hoofnagel. I work at Island County. I'm an associate planner. There's 6 planners that work in Island County within the Planning and Community Development Department. All of us kind of dabble within shoreline permitting and shoreline regulations, things like that. I predominantly am the planner who focuses on a lot of the shoreline work. And so I'm just going to kind of run through some portions of code that are important to consider and then kind of what the procedures are. So yeah, let's get right into it. So for any of you who don't know, I'm just going to do a brief overview. So Island County has a chapter 1705A. This is our Shoreline Master Program. Really, this comes from the Shoreline Management Act, which was enacted in 1971, I believe. And then we have the Washington Administrative Codes, which essentially implements the Shoreline Master Program guidelines. Kind of how are we implementing this act, right? How are we enforcing it? How are we regulating things? And then that filters down to county, local governments having to do their own shoreline master programs, right? And there's a lot of different purposes for this shoreline master program, the act itself. Really, the way that I see it is it's balancing essentially private property rights and the rights of owners to do certain activities and developments on their property while also balancing, and it's kind of not infringing upon the public trust doctrine, the public interest, not affecting the shoreline resources or the ecology, the systems, the geology of the shoreline. And then not only does it have those purposes, but it also lists out what the actual regulations are and then what the procedures are for going through and actually enforcing those regulations. So when it comes to applicability, really the Shoreline Master Program, broadly speaking, applies to any person, entity, government agency doing development or any type of regulated activity within the shoreline jurisdiction. And there's a really kind of a technical term and kind of a broader definition of what the shoreline jurisdiction is. Really what it is, essentially 200 feet landward from the ordinary high water mark in all directions, right? And if you're in that area, you're in the shoreline jurisdiction and you're beholden to essentially the regulations of the Shoreline Master Program. And anytime you want to do some sort of development or activity, you generally, except in very, very limited circumstances, you have to get some sort of, at a minimum, written approval from the county, or you have to get some sort of permit, or you have to essentially get a shoreline exemption, right? Which for all intents and purposes is a permit, but it's like you don't have to do a higher level permit for the activities, right? In our definition section, which by the way, the definition section is a great resource if you're going into our code to kind of figure out if there's some terms or phrases you don't know, the definitions is great. Really for this presentation, the most important thing to think about is what are regulated activities, right? And a lot of things that are most anything's really regulated to some degree, but like when we're thinking about vegetation and drainage, we'd be thinking about things like clearing and grading, removal of vegetation, or using specific types of pesticides or fertilizers, installing drainage, impervious pavements, single-family residence development. Construction really of any kind is going to be a regulated activity. So this is not an exhaustive list, but these are ones that I felt were important to kind of cover. And if I'm going too fast, anyone just let me know. I know I put a lot of words on there. I tried to solidify it down a little bit, but it's kind of common things we see, like I just said, when we're talking about different types of development. Really, the proposals that we generally see deal with, when it comes to like vegetation removal, we usually have people coming in to either prune trees for view maintenance or potentially even remove trees for safety reasons. And I'll get into when we actually allow and how we kind of categorize what is really a safety or hazard tree versus not. Removal of invasive species is another one that we commonly see. Again, clearing and grading just associated with site development for a single family residence. We see a lot of that. And going hand in hand with that is landscaping. So a lot of times we see where people are going to put their lawns, or if they're going to do something broader than that, they'll list out where they're actually adding different types of species and in what quantities associated with their single family residence. We see buffer enhancement. I'll get into buffers in a second within the shoreline jurisdiction. And then when it comes to drainage, a lot of times, again, it's associated with a single family residence. We're talking about like outfalls over a bluff, or rain gardens, or bioswales, splash box, pervious pavement. Things like that are generally what I would be reviewing as part of a single family residence as it relates to drainage. So we're going to kind of get into the conservation code section, vegetation section. So within our code 1705A 090K is really the main section that we would look at, or even someone in the community might want to look at to know what regulations are there for vegetation, either removal, planting, kind of briefly some restoration pieces to it. The first thing to note is when you're in the shoreline jurisdiction, you first need to kind of figure out what jurisdiction you're in, and then you need to figure out what the buffers are and what the setbacks are. So the image that I included here is essentially just a set of buffers per the shoreline designations that you're in. So for example, SR is shoreline residential. You'd have a 30-foot marine buffer. Buffers per the county code are really meant to be kept in a naturally vegetated state. It's very limited in what type of development can occur in a buffer. And generally, you can't really do much with it, right? And there are certain cases, which we'll get into, where you can alter it. Anytime you're trying to remove vegetation, alter vegetation, or even add vegetation, existing native vegetation should really be prioritized. So we want to see people minimizing removal of native species at all costs, really, or just not even being in an area we're going to necessarily disturb it. If you are going to disturb native vegetation, whether it be native or non-native, you have to do some sort of replanting, re-enhancement eventually at some point. And that same principle goes for restoration projects too. We want to ensure that the type of plants you're using or vegetation for restoration is consistent with kind of the nearshore environment. It can't be out of place, right? A lot of times we see people coming in for like landscaping of their house and they put all these plants out there and they like on paper they look great and they might be in the marine buffer, but they're really not the right types of plants for that area. So also it's good to consider what type of plants you want to put there and where you're putting them. Natural features. I think this was talked about a little bit in the previous presentation, but from the county's perspective, things that are naturally occurring on the beach should just be generally left alone. So fallen trees, snags, drift logs, things like that need to stay in the beach, except in very limited situations where it's going to cause a hazard to, public health, safety, or potentially even the environment, right? In some scenarios. So a lot of times we'll have people call and they'll say, hey, we had a storm, for example. We had all these logs come up on our beach. Can we get rid of them? Can we move them somewhere? And what we generally tell people is like, if you're not using any type of machinery, you can move them, but really you need to just move them back into the shoreline. You can't take them off site. You can't chop them up. You can't do anything like that, right? It's very limited on what you can do. Again, unless it's some sort of like real safety, health related issue. Another thing that we commonly get people asking is like, hey, can we top trees? Can we cut off the tops of trees? That's totally prohibited within the shoreline jurisdiction as far as the county goes. You cannot top any trees whatsoever. And it's something we get asked quite frequently. When it comes to the things you can do on actual trees specifically is you can do pruning is really what you're allowed to do. And we have a specific extent. You can do 20 to 25%. And our code actually lists how to calculate that. I'm not going to go into the whole calculations. But this section 1705A 090K covers how we want to quantify that and really how the owners or how you as consultants should be quantifying that pruning of a specific tree. Let's see here. So yeah, kind of like what I said with regulated activities, the shoreline administrator, which would be the director, essentially can either approve with condition or deny the removal of vegetation or the alteration of buffers or even the type of vegetation plans for replanting stuff. They really have the discretion to say yes, no. And then when it comes to clearing, generally handheld stuff is allowable. So sometimes we get owners who are like, oh, we have all this Himalayan blackberry. We just want to go out with hand tools and remove it. And then generally a lot of times people are like, oh yeah, we want to replant it with native stuff. So that's great. They're already on top of it. That's allowable. It's still something that we would have to review. But technically hand tools are much less invasive. When it comes to actually using machinery, especially when it comes to things like tracked excavators or any large scale motorized vehicles, you need to have, it's a little more intensive of what we're going to ask for. You need to have an official reestablishment plan, and then the administrator is going to review it a little bit more critically and determine, again, whether it can be approved, denied, or whether we can alter aspects of the project so you can still do the activity, but in a way that's less intensive, right? Arborist reports. A lot of times people ask, do we need an arborist report, or in what cases do we not need one? As it stands right now, arborist reports are generally required only for alterations or removal of trees, right? And the list that I've put here on the slide is essentially the information we would want in an arborist report. It's just standard information. Where are you doing the work? What is the scope? Well, how large is the area going to be? What species are you going to be impacting, right? What equipment are you going to be using? What are the methods? I mean, just kind of standard information. And what I tell people who ask about this is the more detailed your arborist report can be, generally the less questions we're going to have and the easier the process is going to be. If it's really, really vague, chances are we're going to have to come back and we're going to have to say, hey, you're going to have to cover all of these sections. So just really being thorough when a report is required is going to really help us do our jobs, right? When you look at the images, these are just really rough examples. We probably want something a little bit better than this, but this is kind of the starting point. So for example, you know, taking a photo and actually showing us what trees are you going to be working on, right? And then doing an overhead, you know, kind of like a site plan of key indicators. Where are the trees that you're going to be pruning? What are the trees you're going to be removing potentially? Where's the buffer? Where's vegetation that you might be altering? Those are all things we'd want to see to really understand the work that you're going to do, right? Another big one that comes up is geotechnical reporting. And this is really something that's reviewed by our public works department. They have DVs who have degrees regarding geology and are experts in the field. If you are trying to do some sort of alteration of vegetation, and this even applies to drainage, likely you'll need some sort of geotechnical input, right? And it varies. And what I would say is if you are on a steep and unstable slope, you should contact the county first so we can look at it further and then better advise you what you're going to need. Because it kind of is a case-by-case basis. And the DVs have a better understanding of our land development codes. And a lot of times, for example, if you're doing pruning, but it's on a steep slope, provided you can give us enough information, you may not need geotechnical reporting. But for example, if you actually are saying that there's, for example, a hazard tree and it has to be removed, we want to know, is the root wad being left in place? Like, where's this tree going to go and you've chopped it down? Is it going to affect slope stability? Is it going to affect drainage? These are all things that we'd have to have some sort of geotechnical expert weigh in on before we would make a decision, right? And again, case by case basis. So that's kind of the vegetation portion. If we want to get into kind of drainage, again, most drainage that we see is related with single family residences. So this would be something like appurtenances. And you can see like a dispersion tee, and a lot of these go down on bluffs. Like we have like an outfall that goes down the bluff, but generally things like a garage, decks, utilities, and then things including drainage are also there. Appurtenances generally need to avoid geological hazards, steep slopes, and then when you're doing the work, you want to minimize, you know, where you're taking out vegetation and things like that. And again, you have to like replant and remitigate once you've installed these drainage features. They generally should be located as far away from the ocean as possible, the ordinary high water mark. And also, Lisa, let me know if my time is, if I'm going too fast or too slow.
No, you're doing great.
Okay.
We got one question for you about vegetation, but you can come back to that
Okay.
if you want to keep going with the drainage.
Perfect. Let me just make sure I didn't miss anything important here. Okay, the other thing to consider, and this again goes more back to public works, is that any type of stormwater drainage plan needs to adhere to Ecology's stormwater management manual, as well as an NPDES requirements, which, to be honest with you, I'm less familiar with. And then we also have Chapter 1102 and 1103, which are our land development standards, right? On the right-hand side, this is actually an example from a real project that I review, which I thought was really creative and cool. It was for a single-family residence, and they essentially, I can't remember if they were, I think they were encroaching into their setback a little bit towards the water, and in doing that, you have to mitigate for it. And so their solution was essentially to do a bunch of native plantings within the marine buffer, but then also use that area to do this bioretention, bioswale type system. And it met all my standards. They were essentially enhancing the buffer. They were using native plantings, things like that. Public Works was happy with the design and how it was actually going to drain. So at the end of the day, it was kind of this cool middle ground between managing stormwater and drainage while also managing vegetation and enhancing the buffer. And this was on a parcel which had previously been developed with single family residences. And it was literally just really all lawn. So this was a big improvement. And we were really happy that the owners elected to do this, right? We didn't even have to ask for any of this stuff. They just put it in as part of their plans. And it was, I think, a really cool feature. And if you can see my mouse, this is kind of the bioswale areas on either spot with a planting area in the marine buffer, and then kind of this walkway path leading down the beach. I want to touch on restoration briefly. Unfortunately, we don't see this as often as I think we would like. And I think it's something that as a county, we're trying to figure out ways to make the public more aware of their options when it comes to restoration and try to better incentivize restoration, right? Essentially, beach enhancement restoration is really you're revitalizing the beach. You're trying to put it back as closely as possible to its natural condition, which is almost impossible once it's actually been developed. But that is the intent, right? Is to really improve the ecological systems, the ecological processes, the geologic processes that are occurring in the shoreline, right? Shoreline restoration is a permitted activity in all the shoreline jurisdictions. And then a lot of times there is some degree of clearing and grading or dredging potentially in certain projects, or even filling. And provided those are actually part of a restoration project, then they're also permitted within the shoreline jurisdiction. If they weren't, it would be a higher level permit. It would likely be what we consider a conditional use permit or substantial development permit, right? The other thing that I like to mention to owners, and it's something I'm putting together a little handout for you all as well that I don't have finished, but it will point to a code section where owners who elect to do things like remove hard armor or remove impervious surfaces in their buffer, there are certain incentives, there are certain kind of trade-offs that they can get. I think one of them is like if you remove impervious surface in the buffer, then you can add it somewhere else on the property, provided it's like not in the buffer. So it's kind of like, oh, you want to expand your master bedroom, for example. Okay, well, cool, you can do that, but maybe the trade-off to allow you to maybe go a little bit higher in impervious surface maximums is to remove impervious surfaces somewhere else, right? Let's see. Generally, restoration projects are prioritized, so they kind of get bumped to the top of our list. And we try to make the process as easy as possible for things that are going to result in like a net benefit to the shoreline environment. Depending on the scale of the project, it could either be reviewed as a shoreline substantial development permit or a shoreline exemption, depending on the type of project and things. It's really on a case-by-case basis. We'd have to look at the project further before figuring out the permit type. So that gets into our process and procedures. As a consultant or as an owner, really the first thing you'd want to do is determine, are you in the shoreline jurisdiction? And on the right-hand side, you can list out kind of a color coding of what type of jurisdictions there are within Island County. If you're in the shoreline jurisdiction, you then should determine, are you in a buffer? Are you in a setback? Where's the work occurring? Because that's really going to dictate how strict we're going to be and what we're going to review, right? Essentially, you're going to want to, really in these cases, you want to contact us early because the process for vegetation removal is something that we're kind of trying to work through and work on. So you'd want to contact us and talk over your project first. Based off of that information, we'll provide you with guidance generally about, are you an exempted activity likely, or do you need some sort of higher level permit type? Once that's been determined, you'd fill out like an application, or you'd get an arborist report together or geotechnical reporting, and you'd submit that as an application to the county. And generally it would be planning, myself and other planners, as well as the Public Works Department, again, reviewing your actual projects. And then we make a decision. We either approve with condition, or deny the project, right? That's kind of just a rough bare bones. It's a little more in depth than that, but that's kind of the standards for what we're looking at. So I think kind of in summation, really the most important thing to consider is first, again, are you in the shoreline jurisdiction? If you're outside of the shoreline jurisdiction, you likely don't need any kind of, you don't need a generally you don't need a land use permit except for maybe like a clearing and grading permit. The other thing to think about is, like when an arborist report is required, it's usually only for tree removal, like I said. If a homeowner generally wants to do something on the beach, we still have to review that. It just doesn't require an actual report. I like to throw in the fact that, again, a lot of these things are reviewed on a case-by-case basis. And what I tell people, again, is it's a lot less about the work you're doing. It's more a lot of times about where you're doing the work that trigger specific things. Like, for example, if you're doing work in a buffer, you generally need a biological site assessment. You'll likely need potentially need SEPA depending on the type of project. And again, if you're on a steep and unstable slope, you might need geotechnical reporting. And I think the biggest thing to hone in on is that if you're unsure about anything, contact us as early as possible. We really do want to provide guidance and we want to help people. You know, I understand that kind of like we're government, we're regulating and we're dictating what people can and can't do, but really our intentions are good. At the end of the day, we're people and we're just trying to, again, balance private property rights with the protection, the long-term protection of the shoreline. And we're more than happy to walk people through what code sections might apply, what the procedures are going to be, just to give them all the information, to give you all the information. And I think also to try and make the process as easy as possible, right? The more information you give us, the more information we can give you guys, and then hopefully we can kind of move a project along as efficiently as possible. And then the last thing that I think some people forget, especially owners, is like if you are removing any vegetation, whether it be invasives or non-invasives, you do have to replant. And generally it's at a 1-to-1 ratio that you'd have to do that at. And then lastly, just resources, our IC GeoMap, Island County GeoMap. You can simply Google it. It's a really handy resource. You can search addresses and parcels, and then you can add layers. So you can see things like steep and unstable slopes. You can look at what shoreline jurisdiction you might be in. You can look at forage fish habitat and where that's been mapped. It's really, really handy. It's on our Island County website. There are tutorial videos as well that you can use. So if you're kind of figuring out like, how do I use this software and you're new to it, it'll walk you through how to do that. The Island County Shorelines webpage, you can search and it has useful information, kind of covering what I talked about with the procedures, but more in depth. Like, what do you do? How do you go through this whole process to get a project approved, right? And then the last thing is you can always stop by our offices. We have one office in Coopville. We have an annex on Camino. And then we also have a standard duty line. And if you call that line, you'll be transferred directly to a planner. And then we can start running through all your questions or what type of project you're looking to do. Yeah, I think that kind of covers it. I know it's a lot of information, but I appreciate you folks all listening. So.
That's great, Austin. Thank you. We do have a couple questions, but before we dive into those 3 really great questions, actually, I just want to say too, we know that a lot of you work in Snohomish County as well, and probably across the region. We have a couple handouts that we're going to provide to you that we got from Snohomish County. They didn't have any planners available to speak with you today. But we've got one little handout from them regarding hazardous tree removal. A lot of these are really from the landowner perspective, but it's important, I think, from the contractor perspective to be able to provide these to the landowners as well. So they have kind of similar topics that Austin reviewed. That should I remove and replace trees within native growth protection areas or critical areas, and if they don't pose a threat, they're saying no. One of the other flyers is sort of also a kind of a flow chart for hazardous trees and determining whether or not it can be removed, what permits are required, and then also just forest practice information for those larger scale efforts. And I'm sure as well we'll do some deep dives and provide you with more information on like websites for Snohomish County too. So yeah, so that's that. And as far as a Q&A goes, I can kind of run these real quick if you want. So for the first one was from Tristan. For the replanting requirements, are you considering climate change potentially not being sustainable for native plants? That's a really interesting question. I can talk about it too when you're done about from the restoration point of view.
Yeah, I mean, honestly, that's a great question. It's not really something that we've considered when it comes to actually like revegetation or managing vegetation anywhere. I think that's really an interesting aspect to it, though. We are working on our comp plan, and that's going to touch on some climate resiliency portions. So I don't know if they're covering some of that stuff. I really don't know. That's more of a long range planning thing. But yeah, great question. Wish I had more information for you.
Ellie, do you want to jump in? It looks like you wanted to say something.
Oh, no, I was just marking it that it was being answered
Oh.
live.
Okay. So I know from our perspective, in the restoration world, probably the only plant that we're seeing some challenges with right now, and John can probably talk, more in depth about this as well, is really our native cedars. The Western red cedar is kind of the one plant in the shoreline that is struggling to survive. But what we're finding is simply that we just need a little more kind of care of those plants when we're first putting them in the ground. Making sure that we are giving some really good watering to the plants in the summers right now, which certainly on our high bluffs is a challenge because you don't want to overwater on the bluffs. But we're definitely not seeing really any detriment to any of the general natives. The shrubs are doing great. Nooka rose and snowberries and those typical nearshore plants are not really, they're not struggling, and they're actually adapting quite well. And again, John might be able to speak to this a little bit more from his perspective too. But that's from kind of the restoration point of view. John, you want to touch base? You want to touch in on this a little bit?
Yeah, I think that I think it's an important consideration, especially, not just climate change, but just through development. Like, right, we don't put native plants in dense cities because that's not their habitat. And it's taken some time for people to understand that, we shouldn't be trying to populate our urban areas with native plants because they don't do well there. And we will see more of that eventually through the process of climate change. I do push that a lot in some of my consulting. Not push, but just recommend or kind of throw that option out there that let's look at plants that have a long-term potential through climate change, and not just the typical all native, 100% native everything, but let's just see what other options there are. And I think that should be based in science and based in our expectations. What I think we're potentially seeing a lot of is Douglas fir taking place of other plants like spruce and western red cedar. Their genotypic plasticity, so their ability to adapt to the climate and adapt to everything is limited. We don't see spruce that much, even Oregon. We don't see them much in their what do you call it, their area of growth. I forget that word. The distribution is not as large as it used to be, and I think that Douglas fir, because they're very adaptable, they will just take a lot of those spaces.
Okay, great. Let's see. You've got one that maybe is a question for Valerie. What kind of, but also maybe Austin as well, but what kind of incentives does the county give homeowners to implement restoration?
Yeah, so I can start off with this. I was also planning to do a short overview of the shore friendly program in Island County specifically towards the end of the webinar before we go out. But a big incentive for homeowners from at least the shore friendly perspective is we actually offer mini grants. So we are completely non-regulatory, 100% voluntary. If somebody decides to go through with any recommendations we provide a potential mini grant from anywhere ranging from about $500 to $5,000 to help subsidize the cost for shoreline owners with any particular activity that they are engaging in. So it does have to be something within the specified field of what is recommended for them. And it only pertains to certain activities. So like if they wanted to redo all of their roofing and it was like good for their house, we wouldn't necessarily cover that. But if they wanted to look into drainage management and they wanted to get like drainage designs or have an expert come out with that, we could help with that, if that makes sense.
That's great. Thanks. And yeah, and again, we'll go into more details at the end about all those incentives. And our shore friendly program for Northwest Straits has similar options for Snohomish County and all the other North Sound counties. All right, so next one, Camino has such difficult soil quality to deal with, and whoops, it's moving around. And with the over permittance of wells and communal wells and yearly drought, what kind of water retention techniques has Island County implemented mid-island to help groundwater infiltrate and replenish levels? A little bit out kind of the scope here, but good question.
So to be honest, I don't have a great answer for that. What I would say is if you want to provide your contact information, I can reach out to the Island County Health Department and to Island County Public Works and ask that question for you and see if I can pin down an answer. Generally, water management like that for wells, septic systems, that's reviewed by the Island County Environmental Health Department. So I feel like they would probably have a better answer to that question. So
yeah, septics within the marine shorelines and in the marine, or in the shoreline jurisdiction is a current problem, and it's going to continue to be a problem. So yeah, that's definitely something to think about. Next question is, I see a lot of folks not following the rules in regards to view pruning. How are property owners held accountable? I spoke with a planner years ago who said 2 times the permit fees and mitigation cost when the code isn't followed, assuming they get caught. And I imagine most don't get caught or reported.
yeah, that's a really great question. The way the county works right now, for better or for worse, is generally for code enforcement to take action, we need to have an official complaint from someone in the public. So whether that be a neighbor or someone seeing work that's occurring and then they contact us, we have a code enforcement officer go out there. If there is some sort of infraction, there's a stop work order usually put on or some sort of enforcement letter that's sent. And what we do is, yeah, you have to get permitting for it. And kind of what we do right now is, yeah, you get double fees. You get dinged with double fees for the actual permitting of that type of development. There are more stringent code requirements. At the end of the day, our PA's office, they really decide what actions they want to take, like serious enforcement against. And in those specific situations, owners who do things illegally could face fines of up to $1,000 a day. But it's really case by case basis, and the PA's office really holds the reins for when that happens. The best that we can do in planning without having the PA is really those extra fees that are thrown on there when someone gets caught for an infraction. So we are also moving towards restoration permitting, which has been something that's kind of been lax, but it is something we're trying to focus on as well. So if you clear and grade, for example, like let's say it's associated with a single family residence, we might have you do a shoreline exemption with double fees, with clearing and grading permit fees, all that type of stuff. If you are simply just grading the, marine buffer because you want to put a patio out there, there's a high likelihood you may just have to do a restoration permit. We might not even say, well, try to permit your deck here. We might say, you just need to restore this. You need to go through a restoration permit. So it's something that we look at. Again, it's a case by case basis. We have to look at the infraction. So
we've got 2 more. One should be pretty short, but another one. And then we probably need to move on, but you can keep, putting your questions in the Q&A, and we can answer them as we're going along on the side. So there was one that's a 20 to 25% canopy removal within a 5-year period doesn't permit height management for view for many species. Is there a process for getting a view management plan approved outside of this limitation? Or do property owners need to accept that height management is not practical and they should accept this loss of view? We have steered away from view management for a number of reasons, but this does come up. That's a great question.
The best answer that I have is, again, for better or worse, the code is the code. So what we have now is what we have to work with, right? So.
Yeah, we're trying also through our shore friendly programs, trying to convince people to rethink what their views are, and that having a forested view or, a well-managed property of, primarily native vegetation, certainly in that shoreline buffer, is a different way of looking at it, but they can look at it from the perspective of it's providing them a lot more structure and stability and a lot more habitat that in the long run is going to benefit them too. So we're trying to change perspectives. And then the last one is our shoreline codes similar from county to county in Western Washington. Yeah. Austin, you have anything to say about that?
It varies. I mean, broadly speaking, as far as my understanding goes, no shoreline master program can be less restrictive than the state laws, so the RCWs and the WACs, right? But every county is slightly different. So there are pieces of code that still have to adhere to the actual overarching act and the laws, but they kind of vary from place to place. Like we're Island County, we're an island, we have a very different shoreline potentially in some regards than like even like Whatcom County, right? So there could be some slight differences, right?
All right, Austin, we do have like at least one other in the chat or in the Q&A if you want to maybe pop in there. But I think we want to move on and want to introduce Rob Whitlam from the Department of Archaeology and Historic Preservation. He's going to talk to you about working in the shoreline from the perspective of cultural and historical resources. All right, Rob, you want to try and share your screen there?
Sure, will do. And my voice is coming across, correct?
We can hear you loud and clear. You sound great.
Good. And then let me get it in presentation mode. Did that work?
Yep, now it is. Yep, that's perfect.
Good. Okay, well, hello all on this sunny but cool day. My name's Rob Whitlam. I'm the state archaeologist at the Washington State Department of Archaeology and Historic Preservation. We're a small cabinet agency based in Olympia of around 23 folks. And I'm going to talk today about archaeology of Washington. I'm going to just go through a number of the kinds of sites you can kind of see and maybe even come across in your work as you do shoreline efforts in Western Washington. I'm not going to touch too heavily on the existing laws because as you can see from the prior one, you've got kind of detailed information on the county's shoreline program and the kind of existing local laws, and there are comparable ones at the state level and at the federal level, so that there's a long history of complex legal and kind of societal concerns about protecting our cultural heritage. And those include archaeological sites, burials and cemeteries, significant historic sites, and traditional cultural places of the 29 tribes that are resident in Washington, and also another half dozen or so tribes that reside outside our state today, but had traditional lands within it. So we routinely deal with tribal governments around 30, 35 daily in terms of the number of projects that come across our desk. But going to Washington State and the environments here, there are archaeological sites everywhere. Every jurisdiction, every location has a historic and human use of that past. And how they're manifest and discovered today varies by the kind of environments that they're in, from the kind of shoreline and intertidal sites of Western Washington into your higher altitude forests and even into your glaciated areas. There are a variety of archaeological sites, and the same thing in eastern Washington with this steppe habitat. So how archaeology is manifest there varies over the last 13,000 years, and how local people and our ancestors take and lived in that specific environment and the resources there. We have archaeological sites ranging from below underwater all the way up to sites coming out and being exposed by melting glaciers. It's a particular subfield now in terms of climate change called ice patch archaeology. But one of the things about the human history of Washington is that the environments have changed over time. So here in the center, here we are in the islands, and the current shoreline is right here. This is a paleo shoreline. This is a paleo shoreline. This is a paleo shoreline. Each one has an archaeological site on them dating to different times. So people always love shorelines. We've had major volcanic kind of eruptions and other episodes of very sudden changes. And we've had kind of from the kind of end of the Pleistocene, we had our shorelines and landforms dramatically sculpted by glacial ice. So basically, we've had a wide variety of kind of environmental conditions that have changed and are changing, and that people have had to adapt to and live within. Here's a prairie on lower Puget Sound, and you can see the trees starting to expand into that native prairie. Well, people have been around Washington around 13,000, 14,000 years. These are kind of one of the earliest. This is a Clovis point used to hunt extinct forms of mammoth and mastodons and bison. It's around the size of a sheet of paper, about 12 inches. This is a 10,000-year-old bone needle from the shoreline, a cave site on the Palouse. And then from the peninsula, this is a whaling harpoon, several thousand-year-old whaling harpoon, and where people went out into the ocean and using mussel shell blades with deer antler toggling harpoons and cedar lanyards would hunt offshore large whales. And even today you can go into the forests and find sites such as this, the Mano Matate, that are just right on the ground and exposed. Well, archaeological sites are not only a kind of a testimony to the kind of human past, but also they're a library of information about the biological past. So if you're interested in paleobotanical vegetation shifts over time, look to an archaeological site. These are 10, 11,000-year-old salmon vertebrae from an archaeological site on a river for reconstructing salmon and DNA. And then these are freshwater mussel shells, and other shell species can be used to reconstruct paleo temperature curves. And the faunal remains in the archaeological site also take and indicate species change. This is an Arctic fox. This is from the archaeological site that dates about 10, 11,000 years ago. And this is a contemporary specimen, which is now found in Yukon Territory in Alaska. Here are a series of bison. These are the extinct form of bison antiquus. This is a contemporary current living species, bison. But these extinct forms of bison roamed Washington state. And this, in fact, is as 10, 12,000-year-old bison recovered from Orcas Island. Well, archaeological sites are also a record of the geological past. The shoreline sites here take and demonstrate both archaeology and cultural, but also reflect the geologic strata of tsunami deposits. Here's one on the shoreline where you have the dunes, the Native American occupation, the archaeological site, and then the sand layer by the tsunami that was dated at 1700 AD. In a similar way, I showed you an earlier one of a volcanic eruption. Again, archaeological sites show that strata of different eruptions. I believe these are all St. Helen stratigraphy from an archaeological site, and all the various eruptions going back to Mazama at 79 BP. And then more recent ones of 1472 with a good clear tephra marker there. Well, archaeological sites aren't always visible, and that's particularly true in Washington and Washington shoreline. So here we are in the San Juans. This is a historic site, a British camp. But once you peel back the sod, there's several thousand years of Native American occupancy. And this was a major Native American village. And what happened oftentimes during the settlement of Washington is that the incoming settlers would take and occupy those sites because they were cleared of forests and the rest and were open. And so here's a British occupation of a major tribal site and archaeological site that extends down into the water because the sea level was different at that point in time. Intertidal, we have a wide variety of archaeological features all through the intertidal zone. Here's a individual kind of there. These are rock alignments that are variously functioned as tidal fish traps. When the tide is out, the table is ready to be set, and also kind of a other variety of kind of protective measures. And same thing here in a lake, shoreline setting. This is Chester Morris Lake, and for the last 9,000 years, people have occupied it, but the shoreline has changed under different hydrological regimes. And so you see occupations here, and these pin flags represent different beach strands of the shoreline. And they exist from the surface that you can kind of walk on today to deeply buried sites. And here's another Mazama marker when Mount Mazama blew up, creating Crater Lake in Oregon and laying down its distinctive tephra. And again, here's shorelines of King County. They're putting in a major wastewater facility, and you can see there's a truck there for scale and an individual for scale. So you see the depth that this site has fallen because of subduction earthquake. And this was the site that documented the subduction earthquake plate tectonic of the Seattle fault line. And so that site is about 4,000 years old and was discovered in construction of a major King County facility. When people lived here on the coastline, they had society and a subsistence system that broke the kind of anthropological rules about large, complex societies, hierarchies based on agriculture. Here, people lived and developed those kinds of societies of dense, large-scale construction and villages, hierarchical monumental art, based on natural resources of fish, marine, and upland resources. So Vancouver and Cook, others came here in the 1700s, the first Europeans coming in via the sea. And today, it can be a heavily industrialized area. This is Port Angeles. And once you peel back the industrial overburden and infrastructure, here's a complete village site, the Towetson, major village site of County, and archaeologists discovered it during the construction of a project. So it's a typical midden village site with, again, requiring a kind of trained eye of the archaeologist and tribal cultural staff to recognize the differences in sediment, the kinds of features and artifacts that are shown. At Cape Alava, again, another major village site, one that is unique because a landslide caused by an earthquake buried the site and thus capping it. And so the kind of wooden items that may not normally be preserved were preserved. And so these are wooden, part of a wooden box. And peoples here didn't have pottery, so in order to boil and cook food, they would make watertight wooden boxes out of a single board and then drop heated stones. Fire-cracked rock would be a major kind of signal of the archaeological site. These are archaeologists working with the Makah tribe, recovering the artifacts and the information because of erosion. And we'll probably see more of these kind of activities occurring as sea level rises and coastal archaeological sites are subject to erosion. Same thing along the river systems and riverbanks here, just more sites, and again shows you the kind of stratigraphy and soil development. This site was visited by Lewis and Clark. It's a quathapodal. It's just outside Portland, so you've got a major Chinookan village just a half hour from downtown Portland. All sites kind of are protected in Washington. And again, you can kind of see the evolution of the landscape over time. Again, traditional sites, but today they're reflected by rock features or other elements that are subtly shown on the landscape. This is again the skull dated to 11,700. Extinct form of bisons is thinking of the bison hunters of the San Juans. And so you can kind of see some of the distinctive megafauna that are no longer in Washington, but were there at one time with people hunting them. Another Clovis site. And again, we're often asked, well, geez, it's been farmed, it's been disturbed, there can't be anything there, correct? Wrong. Here's this 12,000-year-old site down about 1.5 feet and discovered when they're putting in the irrigation system. And there it is, 12,000-year-old site with match sets of projectile points used to hunt extinct forms of mammoth mastodon. Many different sites. One of the things that is distinctive about tribes here in Washington is that unlike the settlers that came in with homesteading and pioneering that used agriculture and homesteaded up their piece of land, here Native American peoples had not one home, but many homes. And those homes varied by the season and the kind of resources that were available by the season. And so not all archaeology kind of are flashy, kind of very obvious kind of artifacts. Some are images onto rock faces and surfaces. Others are rock features and other elements that were constructed as part of their use of the landscape for hunting. And here is a shoreline in Whatcom County. This is Ross Lake. And literally this beach here is all artifacts. This is a mine that was used for acquiring toolstone to make artifacts out of. And you're seeing the debris and detritus left after quarrying. And this is the face of that Hosamine chert mine that dates back about 4,000 or 5,000 years. And so literally when you walk on this beach, you can see the artifacts. It's just literally a beach of artifacts. Restoration projects, we get involved in a variety of shoreline restoration activities and salmon habitat. Here is the remnants of a pre-contact ancient weir system for catching salmon. And again, the wooden tips of the stakes are exposed at low water, and some again during excavation for the restoration activity. So there's a wide variety of sites in the shoreline and nearshore. Camas is a major food stuff, and again, when it bloomed, you can see it looks like a lake from a distance. But it was a major carbohydrate and food source for Native American. And you can see the size of some of the cooking pits that were used to roast. And there's a little camas there that was lost. And here's the nature. Some of these archaeological sites are represented by 1/2 ton of rock, fire-cracked rock that was part of the heating element for processing these sites. And of course, we have culturally modified trees. Washington and British Columbia, parts of Oregon and California have very distinctive kind of forests and habitats. Here is a cedar tree, and stone tools were used to notch the base, and they would also notch the top and split off planks or canoe blanks for use in construction. We also have dendroglyphs, again, a historic kind of element of past land use of the forest, and also culturally modified trees that were stripped to make basket trees on the way to huckleberries. So a variety of different fruits and elderberries and huckleberries being used and dried leave very kind of ephemeral signatures on the landscape, but all are protected under a variety of kind of federal, state, and local processes. Shoreline images, there's one along the coast. This is on Clallam County, Wales, and along the rivers. And this is She Who Watches along the Columbia, Tsalagala, who is a famous ancestor that was turned into stone to watch over her people. But you can see vandals have tried to shoot out her eyes. So the area was closed and only allowed for kind of escorted tours. So we have a wide variety of sites that not only reflect kind of artifacts, but also the kind of rock features, pits, and other human use. Clam gardens is something that you may encounter in some of your activities if you're in the nearshore. And again, these go back thousands of years and reflect traditional and tribal use of the intertidal resources and enhancing the habitat for intensification of clamming. And historic archaeology, all of us have ancestors, and so there are historic archaeological sites associated with this. This is the first European settlement in Washington. Mexicans from Nunez, at the settlement called Nunez, Guyana, and here the Spanish settled in 1792, and you can still find the artifacts associated with that early coastal settlement. Hudson's Bay came later and established its kind of presence in Western Washington and actually in the entire state, leaving a wide variety of kind of historic forts. All of us have kind of ancestors that have archaeological sites associated with them. And cultural resource management today, again, we have it here in Washington, but it's everywhere in the U.S. It's a global phenomenon, global kind of discipline. And so wherever your descendants are from, there are probably archaeologists like myself working to protect and preserve and interpret those sites. The Americans kind of showed up with Lewis and Clark along the waterways, and we have the archaeological sites that they visited just literally a couple inches below the surface. This is a Chinookan village at the Pacific County, and you can see the charred planks are still intact. And then homesteading came in, and again, we have historic sites associated with the first homesteaders. This is in Thurston County, associated with the Bush family. And we have other underrepresented communities that made significant early impressions into Washington, the Chinese sites and later Japanese sites in the forests. And we have history still going on today. This is our latest National Historic Landmark, the B reactor. It's where the nuclear age started, and the plutonium that made America's Cold War nuclear arsenal was produced. So today it's in a major kind of restoration efforts, and the huge industrial facilities in a city of 50,000 now is kind of a ghost grid of streets and habitat being reconstructed. Underwater archaeology, again, just off the shore, when you look out, you'll find that there's Native American tribally secured fishing and the sites associated with them, and even shipwrecks. We have a significant collection of historic shipwrecks, military and commercial, and also aircraft. Washington State has a number of WW2 later and earlier aircraft in our lakes, such as Lake Washington. Traditional cultural places is a major kind of concern to protect, and tribal governments are very concerned about making sure those places are saved. This is a 1880s picture. This is a current contemporary picture of the same locale. Again, you can see some of the kind of landscape changes, but continuous use by tribal people over thousands of years that they have been here. Well, I haven't gone much into the complex kind of lattice work of kind of federal, state, and local government, but all of them take and require that if you come across any resources, stop when you see something that you have questions about, secure the area from any further disturbance, and then notify. All of you probably will be given or have from past projects, inadvertent discovery plans, IDPs, UDPs, they have different names, but they all take and emphasize those stop, secure, and notify, the duty to call, particularly if it's human remains. So I think that is the end of my presentation. Am I doing okay for time, Lisa and Haley?
Yep, you're doing great. We got about another 10 minutes.
Are there any questions that you've seen in the chat? Or that people have?
Not seeing any currently. We've got a comment in the chat that says no questions, but that was awesome.
Oh,
Well,
good.
there's
Well, hey,
one in the
that
chat.
means that you guys get to go early for lunch, right?
Yep.
Is that it?
We do have one. We got one from Rob, or from John, asking, do you know if the sunken ships in the Snohomish River Delta are considered an historic site?
Well, all underwater, and it's part of our RCWs. It deals with, Washington State is one of the few states that protect not only underwater shipwrecks, but other elements such as aircraft. So we do have those if they are submerged, historic wrecks on DNR land. We would consider those historic and would require a permit. Typically in Washington, we've seen that because of the nature of the depth, cold water, it is a Herculean effort to undertake kind of recovery efforts on shipwrecks. It's not like the East Coast where you're in shallow kind of, Florida waters with your flippers. I mean, you need submersibles. And so we've had over the years a couple attempts. Most have not been very successful in terms of recovering and doing salvage excavation or recovery. Couple reasons, like I said, that you've got the logistics and physical and the capital requirements to do anything like that. The other thing is that, particularly for the airplanes, what they discovered when the Navy maintains ownership over all World War II and later naval assets. And they did try to recover a Martin Mariner flying boat. You've probably seen some of those in the news as firefighter water drop airplanes now. We do have one, it's very rare, in Lake Washington. But what they discovered when they tried to design a way to lift it is that over the ensuing years, the fine sediments have basically taken and infiltrated the wings and fuselage to such an extent it's like concrete, and you couldn't get the lifting capability to lift these elements without damaging it. So there's just real physical kind of impediments to doing kind of their recovery efforts or salvage like you see on kind of Florida or the Caribbean or things like that. We don't have any, Pirates of the Caribbean gold ships, but every once in a while there's some reports of, vessels that have their safes that we've had one this year. But again, the recovery effort and the money to try to get that is a very high bar. Does that answer your question?
Yeah, sounds like it. Yeah. I can also add, and Rob, maybe you can, touch on this a little bit too. I know, as folks that, since we are working in the shorelines, of the, the greater Puget Sound region, Especially on when we're working on low or no bank areas, our first assumption is that we could very well run into some kind of cultural materials. And so, we certainly take a cautious approach. And for anybody, on the, as far as the participants go, if you are working through the Shore Friendly program with any of your property owners too, and you're working through our grant system, know that there is a pretty extensive review process, as well as any other state or federal grants that you might, maybe your landowners had access to through some local programs. That it's not just, you can't necessarily just go and do work first. You have to go through a whole process of review to determine if if there is a potential for sites and potential for cultural materials. And we've actually been, kind of redesigning some of our planting plans even in sensitive areas. And rather than digging into the ground, we're adding, materials and topsoil and mulch on top of the ground and planting into those areas. It takes a lot longer, I think, for the plants to establish, but it allows us to do work while avoiding impact to cultural materials.
And to note that too, Lisa, it is very important. There is behind the curtain a lot of reviews going on with many eyes, both tribal, professional archaeologists, that pretty much every agency has their own staff of archaeologists that are working during the application process for the reviews and any necessary on-site investigations before there's even a notice to proceed. And usually when the contract is signed and then given. So we deal with around 20,000 projects a year. So we're a small staff. The tribal governments also have small staffs, but all are passionate about kind of their mission of protecting these very important ancestral places.
Yeah, we sort of work at that confluence of protecting cultural resources while also trying to restore the shorelines, and it can be tricky, but we certainly want to make sure that we're respecting, the previous users of our shorelines as well, and the artifacts and materials that might be there too. Rob, that was great. Thank you so much.
So I figured out how to do a little laser pointer here. So that'll be nice. It looks like it doesn't go away, but all right. So shoreline tree care. Let's start. I just wanted to quickly go over some of the goals of this presentation. I'm not really looking at, I think a lot of us here are arborists. We didn't take a tally, but it appears that most of us are arborists or work in trees to some capacity. So I'm not really talking about safety here. If we're pruning trees, climbing trees, accessing them on shorelines, I hope we're doing it safely, but that's not going to be a conversation here, too much at least. I think that the beginning of all good tree management comes during site planning and development. In shorelines, this is particularly important. This is a shoreline site over in, I think this is in Squim. I think most of us as arborists, as tree experts, are asked to look at trees prior to development. A couple of scenarios I commonly have are, where should I put my house, or where should I put my windows so that I could have a nice view? Or another common one is I want to build my house tucked into all these trees. I want to conserve and preserve all these trees, and I want to put my house 10 feet away from this 45-inch diameter Doug fir. How can I do that, or can I do that? And these are important topics to discuss with your homeowner, just that consulting phase or kind of a bidding stage to what is possible on that site. I think this is the perfect place to set expectations that we'll kind of go into the next couple of slides, but the expectations of, is a view possible here? Like, is that the best view, or is your view somewhere else? Can you obtain a view? Can you actually build your house? You could probably build your house next to that 45-inch Doug fir 10 feet away from it, but it might die in the next 5 years. setting those expectations is important at this stage. I always like to think of tree care businesses as, a lot of people think of tree care as removals, but you could spend decades caring for, or a decade, or more caring for, maintaining, and preserving trees, and then eventually removing them. So you kind of have a whole length there of time managing trees and making money. So in this site development planning kind of stage, I want to talk about panoramic views and filtered views. Panoramic views, I kind of see more of as a historic relic. Of course, there are still new sites being developed where they're creating entire panoramic views like we have here, but it's less and less. Predominantly, these are just historical sites that have been maintained in this way for some time. This kind of goes into the conversation Tristan was having earlier about lawns, right? Like this sort of management of shoreline trees and shoreline vegetation is highly requires a lot of maintenance. These trees have to be topped or coppiced or pruned in some way every 3 to 5 years, 2 to 3, 4 years, for them to have that view. This person doesn't have any grass, but that maintenance requirement on a site like this is massive. One thing I like to talk to owners about is, what is your view? And the correct answer is not, or an answer is not just the ocean or the Puget Sound. I really like to say, what is it you're focusing on? What is your view? Let's isolate that view and maybe preserve vegetation in areas that don't emphasize that one view. And there may be a couple of views, but sweeping views is not the answer to the question of what is your view. So this is more of a nice filtered view. We have existing conifers that have been canopy raised to allow for an under canopy view of the Strait. There's some trees growing off in the distance that have been also canopy pruned or windowed. And there is some vegetation on the crest or near the crest. This was a compliance site. They did over excavate, and they were being required to replant that area to the right with a little bit of some more native vegetation. But this is a site that requires less maintenance, and you keep that structure and you keep that stability that the trees provide. This is what I recommend most clients perform. It is a balancing act between long-term maintenance, the net slope stability, and the enjoyment the property owner has. And I think it's our job to kind of work out that balance and figure out the best technique as to manage it. This is another good filtered view in Cala Point, a large HOA in Port Townsend area. This is a unique site that was it's interesting because the green belt that you see the trees in here and the entire slope was or is owned and maintained by the HOA. So when it was short platted and developed, the homeowners own their lots, but everything else is owned and managed by the HOA. So when the owners here want to maintain their views or do some sort of hazard tree reduction or pruning or whatnot, they have to first go through the HOA, and then the HOA develops a plan and sends that to the county. So much more, logistically simpler than just 200 homeowners trying to request view permits and managing isolated views. Is the view achievable? I think this is a really good point to discuss during site planning and development. This is Patrick Haley with Darrell Emerald's Tree Service in Kitsap County. So the HOA owns the land above, private property owner owns the land below in all these trees. In the 80s, the HOA, when the HOA was developed, maybe the 70s or 80s, they had these photographs showing this just panoramic view, a view of everything there. It was just clear cut. They've in that time, since they've had, I think, 4 or 5 landslides. But nonetheless, they wanted to go back to that. They wanted to go back to their clear cut from the 80s. which, is not realistic these days. This was about 240 feet to the shoreline. So they're, between their view and their houses was about 240 feet of trees. So their view, the view was not very achievable. There just wasn't much of an option. I think that should be discussed with owners, especially when those views transfer across multiple property owners like they do here. One interesting thing that happened on this project, which I think is a good thing to think about, is that this was permitted, but in some phase of the permitting, and there was some legal issues involved as well, but in some phase of that, the county ended up turning the recommendations I had for some like 20% live canopy reductions or live foliage reductions to a 20% branch reduction. So branches of the tree, you can remove 20% of them as opposed to the living vegetation. And the tree care company, and the homeowners were like, well, if we can remove 20% of the branches, which branches are we going to remove? The lowest branches, because they have more foliage blocking the view. So it's just something about language. It's good to be precise. Removing 20% of the branches at some places removed, much more than 20% of the live foliage. Tree protection during construction, pretty important topic during site development. Preserving existing trees, I think, is generally a more effective and superior technique than to planting a bunch of new trees. That's not always the case. There's sometimes it doesn't work, but I really think preserving existing established trees is very important. And especially when the owner who's going through this process and may be paying the consulting arborist or the tree care company to help preserve, and maybe thinking about preserving the trees, doesn't understand, or the contractors don't understand that, putting all of their staging material and their heavy equipment in under the roots or on top of the roots under the canopy of a tree, or using your excavator and bumping into the trees, causing damage, those trees are going to have to be removed in 5 or 10 years anyways, probably less than 10 years. So even with the intention to save and preserve the trees, the eventuality is that they were removed anyways. Here we have two techniques. The one on the right is just 2x4s or 4x4s wrapped around trees with construction fencing or some material, just so that when your your excavator operator who is focused on their objective of whatever it may be, and they might not be paying attention to the trees. If they bump a tree, it doesn't just cause a giant gouge in the tree and that later becomes infected and causes a decay. This can be easily installed, easily removed when it's done. Pretty quick and easy way to just save the trunk of the tree. On the right, we have this huge staging area under this. I think this is a red oak. All of that soil is heavily compacted. They probably were doing like equipment washing and cement washing and whatnot in that area as well. Those soils will have to be rejuvenated and decompacted for that tree to really survive well in the future. Things like this can be mitigated with typically you're going to put down erosion control netting, like coir netting, 6 to 8 inches of wood chip, and on top of that 7/8 inch or 1 inch plywood or steel steel plates, so that we can decompact or not decompact, but the machinery that drives on top of that is not compacting the soil like it would be typically. And then the mulch can be reused later on after construction is over. Something I see common in all developments near trees, but shorelines also, is just overburdening of the root plate. Here's 2 trees. The one on the left, this is a Doug fir. This, I think, was overburdened almost 18 inches. So 18 inches of soil, the excavator or the dozer or whatever it was, grading the site out and pushed on top of the existing root plate about 18, 20 inches of soil. The one on the right was a hemlock, much less, about 8 inches here, maybe 12 inches. The effect this has on trees is very specific to the type of soil and the species. We'll see a tree in a second that did not have any effect whatsoever, really. But mostly, or typically, conifers will have a more significant impact on this. And the way to relieve this is just by removing that soil, typically by hand or pneumatic excavation, or removing it without the use of an excavator. And then possibly decompacting the soil beneath it. So I think this is an interesting tree. This is just this is a picture from Dressy Brighton from Arbor Dreams in Oak Harbor. This was a red alder that you can see here had an original root plate. This was growing on a slope, very sandy soils. So it had a root plate. It had one landslide, covered that root plate. We have epicormic roots, so new roots sprouting from above that root plate. We have another landslide, caused a third iteration of epicormic sprouts, or I guess second, epicormic sprouts, and then another landslide and a whole other thing of epicormic sprouts. And then eventually it all failed, came down the hill with a bigger landslide. But I think it's interesting just to really understand that trees can sometimes adapt to their growing conditions in ways that we don't expect. This tree was buried in 8 feet of soil, sandy, very sandy soil, well draining, and it persisted for a while. So vertical mulching, I don't have a slide here of radial mulching, but radial mulching is similar to what this looks like. You can kind of see here. So this trench, this is radial mulching. In this trench here, maybe radial mulching. Radial mulching is typically like a sun pattern coming out from the trunk of the tree, 18, 24 inches deep. Vertical mulching is the same, 18 to 24 to 30 inches deep. 3 to 4 inches diameter. Both of these photos here are using an air spade, a pneumatic excavation device. I don't think we need to use air spades all the time for all vertical mulching techniques. I've seen a lot of successful vertical mulching done with soil augers with a 3 or 4 inch diameter tip, or a 3 or 4 inch diameter auger bit. That probably does result in some root, cutting root issues, but I think that just because you don't have an air spade doesn't mean you can't do vertical mulching. There was a study just by Davey Tree recently where they did vertical mulching with a earth auger and a bit, 3 inch diameter bit over maybe 100 acres of urban trees, and those trees are doing very well. So the idea here is that you're excavating a portion of compacted soil, removing that layer of compaction soil, that area compacted soil, and replenishing it with compost, maybe some biochar, maybe some native soil material if you can find it, just to keep that synergy with the mycelium and mycorrhizae. There have been some studies done with adding worms to your vertical mulch replenishment. I don't believe there are any native worms in Western Washington. So that maybe before we start adding a bunch of worms into the soil, maybe that needs to be researched further. But typically it's 90% compost, 5 or 10% biochar. And then if you have the availability of some just native soil, you can throw in there as well. Native soil with mycelium, that would be beneficial. We can also add, store-bought mycelium, but just make sure that's a local source. Vertical mulching in general can be less time consuming than radial mulching. Oh, and one other important thing. So I think the word mulching in these, I don't really fully understand why they're called mulching. I have seen people add wood chip mulch back into these holes. We'll talk about it later, but adding or tilling in wood chip mulch is not a good idea. What that does is it deprives that area of soil from nitrogen, especially if you till in wood chip or add wood chip in these subgrade environments. So don't add wood chip, just soil, non-compacted soil, weed-free soil, or compost. All right, so a little conversation, we're getting out from the site planning, a little conversation about tree risk. I would ask, if people are track certified or track qualified, tree risk assessment qualified, put it in the chat so we know. I know there's a few people here at least who are track qualified. But tree risk is a complicated subject. It's a very large subject. I recommend any arborist who does any work on trees to get their track certification. It's $600. It's not very much money. And just the information that you obtain from that class is very useful. And the concepts, the methodologies that are used are just a very useful thing. In the track methodologies, in the way that we look at tree risk, it's primarily focused on acute risk. So that's a risk of tree failure, a tree falling over, a branch falling, the top of a tree, a crown breaking and falling on something. These acute risks that occur they occur at once. The risk is an acute risk. It occurs at one time. It doesn't really examine the idea of chronic risk too well. But trees do have chronic risks, and that's something that I think we should be thinking about when we evaluate tree risk. Chronic risks of trees may include there's development over in Issaquah or North Bend, where that fellow planted. There's a couple dozen houses with redwoods or sequoias just 5 feet from the house, and they're all they all have their own crawl spaces, stem walls. And a chronic risk of those trees is that they will and have damaged all of those crawl spaces. They've damaged the foundation. So it's not an immediate, short-term risk. It's a long-term thing to think about, but it is a risk that tree, it is a risk of having that tree. Same thing with wildfire. Trees have risk of wildfire. Equally slopes, on slopes, just the presence of a dead tree that may fail and then cause a landslide and then cause subsequent erosion can be a risk that tree presents. When we look at tree risk, we're looking at 3 basic ideas, and that's targets. What is the tree going to touch or hit or interact with? What is the exposure of that? How often may that occur? And then what are the consequences of that occurring? What happens when that occurs? An example is like a branch falling on a house, a small branch. The exposure is all the time because the house is present, it's there. But the consequence is very small, right? You have a small branch fall on a roof, your consequence is minute. When you have trees that are undermined on slopes, like the one on the right, this cave went back about 2 more feet beyond the center, the centermost area of the tree. Or you have dead trees on slopes that are just at the edge of the crest. That is the potential for failure and risk of landslides, risk of erosion based on that. These trees shouldn't necessarily be removed. We'll go into that, but at least converted into habitat trees, keep the main stem of the tree at a reduced height, remove the top if it's safe to, obviously if it's safe to do so. But these are things we should be thinking about in relation to tree risk on slopes. There's another tree. This was in Fort Townsend, where obviously this tree fell out, and this was in Squim actually. This is yeah, and it caused a bit of erosion up atop. Luckily, there's no homes in this area, so the erosion it caused was not very significant. So here's a little diagram that we've used this technique before, and I've recommended this, and I've seen other people recommend it. But when we do have tree failure on the crest of a slope, and this is more specific to the crest of a slope, not really landward, and not necessarily on the slope face itself, but on the crest where you have, the crest is where the upland environment meets your slope and begins to downgrade. When that tree fails, if it fails, and it uproots, you know, you see a good 10 or 15 feet of soil uplifted, causing a cavity in your crest and in your slope. That cavity then causes erosion, and potentially it's basically an active landslide, and you will see further erosion. So in this scenario, if your house was, you know, right here, that's a situation you want to mitigate. So typically what we do is put down erosion control logs, like coir logs. We'll have some photos of those later on, but coir logs around your cavity caused by the tree failure. And then at some point you'll want to either put down fabric, plants, straw, wood chip, or hydroseed the exposed soil caused by the root, the root failure. You're basically trying to stop water, stop sheet flow from entering the exposed soil. So habitat trees, of course, this is something important to think about. You know, if we can preserve vertical woody structure, trunks and whatnot, I think it's very important. There's a lot of techniques involved in actually, making your habitat tree or your wildlife snag look more natural, and also more quickly adaptable to habitat, or more quickly adaptable to the wildlife that use the habitat. So here you can see a pretty, this is a fairly good job at a coronet style pruning or fracture pruning atop. So it's not just this is a dead tree, but it's not just a topping wound. They make it look a little fractured. I've seen very good fracture pruning, and I've seen very bad fracture pruning. And I think this is somewhere in the middle. This is pretty good. And here they're building a little, nest, a little cavity with a chisel and an axe. At which point I think they're going to put back the wood they cut out at some point. And you can also see that there's some perching branches remaining. If it's possible to retain some perching branches, that's a good thing we want to keep. These smaller branches, the ones that are 1 or 2 inches, I don't think that's really doing anything. But these ones that are 3 and 4 and 5 inches, if we have those branches and we can retain the stub or retain 2 or 3 feet of them, that's a nice wildlife snag. We just want to make sure they don't, those branches don't fall. The typical height of a habitat snag conversion from a dead tree or a dying tree is going to be, the height of that final product is going to be less than the distance of that tree to your house or your structure, because eventually it will at some point decay and fall down. When considering this tree removal, and when just kind of thinking about how all this works in the shoreline environment, I think we come back to the idea of, the best time to plant a tree is 20 years ago, and the next best is now. The next best time is now. If we simply visit a homeowner's site and say this tree is dead, let's cut it out, and it's removed, we have these roots persist in the soil for some amount of time. Those roots don't just decay and die immediately. They're still there, providing some function with shear strength. The science behind a lot of this goes back to the early 80s. It's been refined a few times, but this concept is the window of vulnerability. And that is the time difference between how long it takes these roots of cut trees to decay and no longer provide a mechanical service, and then how long it takes for our new trees, in shorelines, like our mitigation trees, to actually provide any reasonable root reinforcement. And it's usually around 4 to 8 years is kind of, I think this graph is, maybe 2 to 8 years. I've seen some others where we're getting a little further out in time where it takes our new vegetation to really compensate for the loss of roots. But generally speaking, there's a window there where the slope has less shear strength because of your trees are decaying and your other trees are haven't grown yet. So, my recommendation is if you see a tree dying, if you see a tree not doing well on a shoreline environment, let's just plant a new tree now and then come back in 5 years and then you can cut it down. That's just the recommendation I give most homeowners, is let's plant now, and then when the time comes to remove the tree, you'll have some root stability in your new trees. So tree topping, I think this is just an interesting topic, and we should think about it. I don't condone tree topping in general, but I think that this scenario, this is on Bainbridge Island. These trees have been topped for about 40 years annually. So talk about maintenance. This maintenance cost is huge. Nonetheless, it occurs every year. They top these Doug firs. At this point, these Doug firs, I'll show you the next slide, but the wounds are fairly small. There's not much regrowth. There's not much decay. The trees are generally healthy. If the homeowner hadn't topped these, they may have grown to the full size, whatnot. But the other option is they would have just been removed. They would have been cut down and maybe some shrubs planted. So if my two options were shrubs in this area or topped Doug firs, I would take some topped Doug firs. These are only maybe 30 feet high. They're not very large at all. Here you can see the wounds. Obviously topping reduces tree survivability. It reduces the duration of life a tree has. But in this scenario, I think it increased their life by not being removed. Again, very expensive. We've talked about this a couple of times, but where is the best place to put branches and logs? And by that I mean large woody debris and pretty coarse woody debris. Coarse woody debris is like what you would have in between your large woody and your foliage. So like branches maybe in the 2 to 8 inch diameter range. Where do you put all those? And I like to think about where they would have fallen naturally, and that is the slope and then the beach. In some scenarios, you can't really drag wood down to the beach too well, but in some areas you can actually just kind of push it down right to the beach, in one way or the other. Usually in larger specimens, right? Like I've seen some people cut trees into basically 18-inch sections and then put them on the beach, and that's really not providing the function we want. Those are just going to be washed away the next high tide. So if we can keep those logs fairly large, fairly long, and put them on the beach, that's a good option. There is, Austin mentioned some factor of geotechnical science in relation to this, and I think it's important to look at it through our arborist perspective as well. And I recommend you provide your opinions to some geotechnical engineers. I've had numerous geotechnical engineers just state that the weight of a dead tree on a slope is greater than the weight of the living tree on a slope. and I had to talk to them about that, you know, when trees decay, they become lighter. There's never a point in a tree's life, or there's never a point in a tree's decay where it becomes heavier than it was during when it was green wood. And equally, you know, you can imagine the surface area of a tree on a slope, 24 inches diameter, compared to 50 feet long on a slope. It's very different. And in all those situations, the geotechnical engineer agreed with me and said, okay, let's just leave the tree on the slope. There are some scenarios that doesn't work, like especially if there are houses at the bottom of the slope. Evan mentioned, you know, retaining wood on your slope. So I guess two things, right? If you can get the wood to the beach, that's great. Leave it on the beach. If you can't, leave it on the slope. If it's safe. There's a lot of different mechanisms to keep that wood there on the slope. You know, one is just felling it in a direction where it's behind or uphill of larger stumps, and just kind of can remain there naturally without sliding down. I have seen different people use, you know, wire rope and chains to secure logs on the slope uphill. I think that works. You know, it's an effective way to do it. I would, you know, there's always the thing about like how long does it last for? If it's wire rope and chains, it's probably gonna last for a while. You know, is there potential for the tree that it's anchored to grow so large that it girdles itself on that chain? But I think, you know, securing logs to slopes, that I've seen that done, and I think that's fine as long as it's, you know, well considered, well thought about in the long term. This does not relate to fine trimmings, little clippings. We do not want to put our little branch or leaves, fine foliage, you know, clippings, landscape clippings, grass, things like that. We don't want that on the slope. What we see with that material is the pile of your fine foliage, your clippings, trimmings, black grass. That pile, you know, kills all the surface, all the ground cover growing on the slope underneath it. So that's all dead. And then it also acts like it acts as mulch, so it retains water. So that area between your native soil, your native slope, and your pile of debris then becomes slick. It's a very slick area, and that slickness will kind of pull itself down and cause erosion, cause landslides. So the fine foliar material, that we don't want to leave on the slope. If you can get it to the beach, that's great. If not, it probably should go up the hill into the chipper. So I think we probably know, you know, windowing trees, canopy raising, pretty common techniques in view management. Obviously, you know, canopy raising, we don't want to canopy raise a tree to look like a truffula tree. We don't want that all the way up here. Be concerned about going above 50% of your live crown ratio on a tree, especially a conifer. We have just that elevated center of gravity can just knock a tree over. So you might be creating risk in that way. Here's a tree by Evan. Evan sent me this. Evan Sussman's in the audience today. You know, I think this is a good technique. I never asked Evan, but I'd imagine that these red alders are not growing right here at the crest of the slope. They're probably 20, 30, 40, 50 feet tall. And I commonly see this where we'll have a tree service or a landscaper come in and cut trees down at waist height when they were growing 40 feet below the view line. And it's like, well, do we really need to eliminate all of that function, all of that plant function from grade or, you know, waist level to 30 and 40 feet when your view is at 42 feet or whatnot? You know, how can we conserve that vegetation below while still getting your view? And there's different ways, you know, there's many different ways, but windowing trees is an opportunity. Just pruning out the leaves and branches in the view. So Evan says, yeah, those trees originate on the slope about 40 feet down. So yeah, if we cut them down, you're losing 40 feet of tree. Coppicing, modified coppicing. This is a pretty common technique in shoreline tree care that I see, primarily big leaf maples, also cottonwoods occasionally, dogwoods, and shrubbery. But this is a regenerative tree maintenance method. You know, these trees have to regenerate naturally. Coppicing a Douglas fir isn't really going to work. That tree's dead. These trees here, these big leaf maples, these have been coppiced, I believe, 6 times. And and they grow back well. I think it's done every 4 to 5 years, they're coppiced. And they regrow. Is it the best technique to manage tree health? Certainly not. Is it a good technique to manage a homeowner's desire for a view and sustain habitat, some amount of habitat, and slope stability? You know, it's a good compromise. Coppicing is just, in case we don't know, like if we have a single stemmed big leaf maple, maybe 12 inches or 18 inches or less, or preferably less, if that's cut at the ground like this, we'll see resprouting, epichromtic sprouts that turn into this and this over time. And in the long term, we'll turn into this. So coppicing is one of those things similar to, coppicing is one of those things that we really need to think about the long-term effect. You know, big leaf maples don't grow. We see a lot of these. I'm sure everyone's seen these. Big leaf maples don't grow like this naturally. This tree was logged. It was cut down when this was last logged. It regrew into this coppiced format, and then just kept growing and growing, eliminating, or the less competitive branches went away. The more dominant came and became larger. These are all generally not secured well. So the structure involved in this trunk, these many trunks, is not well secured, and we commonly see these trees fall apart basically. So if you're coppicing trees, just take into account the long-term effect that has. I think I'm running. Was this a 45-minute presentation or a 40-minute?
Either or.
Okay, I think we're going 45. I'm trying to slow down because there's no questions yet, but it's the Zoom. So crown reduction pruning, this is in the picture of Evan Sussman sent me. I think I'm not going to go into too much of crown reduction pruning, but I do see a lot of tree services try to say they're doing crown reduction pruning when they're just topping trees. They're different. They're vastly different. And my one real recommendation for crown reduction pruning is to get up in the tree. Like I'll see tree services and arborists, some arborists say they're doing crown reduction pruning, and they'll be down here. Get in the tree, get pretty high. Crown reduction pruning is pruning tips. We're not pruning large branches. So just something to take into consideration. If people don't have this book, it's recommended. Dr. Edward Gilman, University of Florida. This book, the 3rd edition, came out in 2011. So it's not the repository for the best available science, but it is a good foundational element of tree pruning, the illustrated guide to pruning. I'm not going to talk about this too much. This is indiscriminate tree topping. This is the tree topping that's done. That's just all these trees died, every single one. This was for review in Tacoma. Every one of these Doug firs died the next year. So this kind of topping, if we're topping trees that are 24 inches diameter or 18 inches diameter at the at the topping wound, like Douglas firs, conifers, those trees will not persist. I want to have a quick conversation about wind sailing. I still see wind sailing occurring, especially on shoreline environments. The desire, or I guess the intent for wind sailing is removing every other branch along a stem. So like every 1 or 2, 3 branches, you just cut it out all the way up to the top of the tree. And the concept here is that you are thereby reducing aerodynamic drag in that canopy. So more air can pass through the canopy unobstructed, get to the other side of the tree, and the tree then has less wind load at its base or at its stems. I think it's the concept made sense. It makes, it's theoretically it makes sense, but scientifically evidence-based, it does not work. A predominant mode of wind load reduction in trees is kind of a principle taken from forestry, the concept of crown clashing, when trees themselves butt up against each other and reduce or damp loads from wind, that clashing that they have, that happens independently in branches too. So with those branches that are removed, well, those branches before they were removed could butt up against each other, rub onto each other, and damp their loads. So reduce the wind energy applied back to those branches. But now that half of them are removed, those branches are able to extend twice as long or more than they did prior to. Also, it's pretty well understood that the mechanism that trees use to reduce wind loads is by the oscillation of their branches, by the movement of branches, the movement of the trunk. That's how they manage wind loads. So if we remove all of those branches and those different methods of wind load reduction, then we're actually increasing the potential for branch failure and trunk failure. Sorry, I got stuck there. A good method for this isn't really necessarily related to shorelines, but a good technique instead of wind sailing is limited production. This is a drawing that Nicholas Dankers did a long time ago when he worked for Tree Solutions. It's basically we're looking at the canopy of a conifer and just bringing that canopy inwards. We're not pruning the inside of the canopy, not the branches on the inside, but just the tips. That's that peripheral limb reduction, canopy reduction, just to bring in the branches that may, in these high wind situations, may be oscillating too much, not clashing onto each other or their neighbors, and then breaking off. Usually this is done with a pretty small diameter branches, 1 to 2 inches. Many small cuts are less impactful than large cuts. And one common thing I recommend here is just to put down the chainsaw, use pole snips or some other technique to, make small cuts. So when's the best time to prune? It's kind of a difficult question, I think. So if you prune in the summertime, coat it. Compartmentalization of damage in trees will occur quicker. It'll happen kind of immediately. That tree is active, coat it occurs very quickly. If you do it in winter, coat it is not occurring, and you'll have to wait until spring to have those chemical processes begin. That being said, there are numerous fungi that persist in winter and less so in summer. So it kind of takes a good eye to see what's around you. Like if you're working in a forested area with a lot of potential fungal pathogens nearby you, maybe just do it in summertime so you can reduce the risk of contamination. But if you're working on isolated trees with less fungal influence in the nearby proximity, then I'd probably wait till winter I'd probably do it in summertime when the tree can heal itself. Dr. Dirk Juzefikin is coming out with a new book. He released the Code It principle along with a few others, I think in 2014. He's releasing a new one in 2025. That should say 2025. It should be released this month or next month by the ISA. So I'd recommend, if you want to learn more about the Code It and how compartmentalization of damage in trees works, get that book. So recap, I'll leave that there. And it looks like we have some questions.
Yeah, do you want me to read those to you, John?
Yeah, sure.
Okay. Our first question from Tristan says, I read an article in the New York Times about the longevity of a stump, how the tree remains alive for years to come. I don't remember the timeline, but I typically recommend retaining a significant stump on a slope for this reason. Do you have data on the life of a stump 2 to 3 feet in height or more?
No. I have not seen anything that relates height of stump in relation to that. Or, you know, I mean, even more so, it could be, if it was 10 feet tall, it'd be a snag potentially, and how that affects it. I don't know. You know, I do see in some more well-forested areas, you know, going back to that slide from UW, Dr. Bob Edmonds, showing the tree grafting. I think most, you know, most arborists who have worked in the forest and seen a lot of forest trees have probably seen Doug firs that have been grafted over with, not grafted over, but have grown their stumps over after logging or been, after they've been culled with new bark. And, you know, there sometimes in very dense forests, it is a potential for, you know, cutting down a Douglas fir, and that Douglas fir, those roots being grafted on by nearby Douglas fir and the nearby trees, retaining those roots as living, you know, using those roots of that dead tree. And in those situations, the stump remains generally you know, mostly undecayed, or at least the rate of decay is much less, and the roots are still there. I don't think there's any way to predict that in practice, but it is a, you know, I think it's a consideration.
Yeah. Wow. Okay, next question. Is there a better approach being studied that does prioritize tree health? That feels pretty important to restoration efforts more than maintaining views. It could have been in relation to a certain section, and I'm not sure.
Coppicing, probably. Yeah.
Yes, about coppicing. Yeah.
Yeah, I mean, I think one common tactic, I think, is just, you know, going into the maintenance ideas of coppicing. It's repetitive, right? There's no end to it. It has to be done every couple of years. Rather than coppicing, you know, most of the time what I recommend for a diligent homeowner is just to kill that tree and put in new trees, potentially not in that order. Put in new trees, and then that tree's then dead. You would want to kill that tree once the nearby trees have regrown. If it's not, you know, if there's no risk of that coppiced tree failing, breaking away at that stump and failing into other trees or other structures, maybe retaining it. You know, retaining it is fine. That doesn't maintain views. I think once a tree has been coppiced, you're more likely, you know, at that point, even a canopy raise is not going to work out because you have 15 branches going into the view rather than a single trunk. So yeah, once you have committed to coppicing, you're kind of stuck in there without replacing the tree. But prior to coppicing, you know, the best recommended practice is just to elevate the canopy of that trunk, remove the branches, so you can have a view underneath the canopy.
Great. I don't see any more questions. Do you need a break, John, or you feel good to keep going?
Yeah, I can keep going.
Okay.
I just lost my there it is. And I just wanted to comment too, where did I see Evan comment on Cecil? Maybe that was just to me.
No, that was in the, it was in the Q&A.
Okay.
Yeah,
So
you can click on the
I-
answered.
I think that's a great class. The Cecil is a sort of an erosion and sediment control lead. It's a mechanism stormwater professionals use to be able to, or to allow them to write plans. I don't write those plans. I don't, that's not what I have the certification for. But the information provided in the classes is really useful. You can write SWIPs, stormwater management. I don't even know what SWIP stands for. But yeah, just the certification, the class itself is really, really useful, and I recommend it in just identifying and managing water.
Yeah, I made a comment too there that I know that many of the permits that we receive for shoreline restoration projects, it's generally required depending on the amount of sediment that might be moved, or if you're, in our case, if we're removing shoreline armor, it's required that there's a Cecil on the crew in order to make sure that stormwater is being properly managed. So it's a benefit to you as contractors to have somebody on your crew that is Cecil certified so that you don't potentially have to go and contract that out to somebody else.
All right, let me my screen changed
It's,
around.
as John's kind of getting this one going too, from the shore friendly perspective, weed control, especially when we're looking at ivy and blackberry and some of those really common invasives on our slopes is a big issue that we face with a lot of our shoreline landowners. So we have a lot of questions that come up with landowners on this topic about how to manage it, and a lot of misinformation about the benefits in some cases of ivy in particular to maintaining a slope. All right, here we go.
All right, you see that? Yeah, I just had a client 2 weeks ago who, when I told them ivy is not a beneficial plant on a slope, they were a little shocked. They thought that it was a great plant to have on their slope. So it still is a thing that we need to educate people on. All right, so this is about weed control, restoration, slope rehabilitation, and techniques in that. So this was a question in the live presentation, but I predict that the noxious weeds and invasive plants we have in Comino Island, or basically Island County, or Scotch broom, blackberry, English ivy, Irish ivy, and all the others. We'll go through some of them right now. This presentation is based, we're going to have a couple of informational slides kind of going over different plants, and then we'll have a whole section just on like practice and what techniques are used in the field. So to Cystis scoparus Scotch broom, I'm sure everyone's pretty familiar with this plant. I'm not going to go over too much of these in depth. I think the latter half of the presentation is more rigorous and more maybe exciting. And I think most people have a good idea of some of these plants, but I'm going to go over just common maybe misconceptions or common just important things that we need to keep in mind. Scotch broom seeds last forever. They last through fire and through water, flooding. Their seeds, upwards of 80 to 100 years potentially. They typically grow on drier slopes, drier areas. They like to be exposed to sunlight. I think the most common technique to manage these is with herbicide. But something we see commonly, at least 10 years ago commonly, was using weed wrenches, and we see it less now, but I don't like to use weed wrenches. Weed wrenches are basically this big orange, or always orange, wrench that you put on the ground and you pull, and it grasps the stem of the plant and it rips it out of the ground. You know, I think that when we do that, what I see the following year is just 24 Scotch broom plants growing out of that newly tilled soil. It's just like tilling your garden before you throw your carrots in. That's, you know, in the spring. So when we're ripping out these plants, we're just exposing soil, tilling soil, and these Scotch broom loves growing in disturbed areas. That's what it does. It grows in disturbed soil. So another technique to manage them is just cutting them down after flowering. If you do that, you probably want to remove the seeds. But you know, in the time frame where they are drought stressed in late summer and stressed out from their reproduction cycle, if you cut them at the ground, they typically can die off. Himalayan blackberry, Rubus americanus. Something that we see commonly with a lot of our invasives is that they grow year round. In the wintertime, they do grow less. But a lot of these plants are growing just kind of year round. They don't have a good dormancy. One thing I commonly mention to homeowners is that Norwegian rats really love to live in blackberries. So it's kind of another incentive for them to want to manage their population. There's been studies that show that mowing it down takes upwards of 10 years to kill the rootstocks. And I'm sure we've all dug out blackberries and seen their giant tubers. You know, cutting them down is a single season maintenance activity, but it doesn't really succeed in killing the plants. Digging them up on slopes is not a, you know, we don't want to really dig these up on slopes. Causing that disturbing soil on slopes is something we'll talk about later, but it's not really, it's not a good idea. Herbicide is commonly used for blackberries. This is a site. So in using herbicides, what we commonly do, and I'll talk about more about herbicides later on, but what we commonly do with blackberry is we'll mulch it down into, this was mulched down with a excavator with a mulching head. This was a 6 foot tall patch of blackberry, and spraying that as an applicator. You know, you're going to be spraying into the air. You might have drift, you know, wind blowing your herbicide. It's not something it's really safe to do. You don't want to, and then also the volume of herbicide on a 6 foot tall patch versus this is much greater. So we cut it all down, leave the mulch on site typically, and then when it regrows, we spray the regrowth. That way we're just using less herbicide. One important thing here is, you know, I mentioned in the last presentation not to put fine mulch on your slope like this. I think it is kind of dependent. Blackberry mulch I've never seen issues with, and I think it's because it's more granular. It's not very fine, either inch diameter stalks, very woody. They don't hold much moisture because of how woody they are, or how woody isn't the right word, but they're just they don't hold much moisture. So I've never seen any issues with this kind of mulching of blackberry on slopes, at least if it's thin. Maybe if it was, you know, a 2 or 3 foot tall patch of blackberry mulch, that would be a consideration. So Hedera helix and Hedera hibernica are English and Irish ivy. There's you can tell them apart. It's kind of difficult, but it's not really relevant. They both do the same thing. And there's also a dozen or 2 dozen, 3 dozen cultivars of ivy that look a little bit different, but you know, they generally act in the same way and grow in the same way. What I commonly see occur with trees that have been succumbed by aerial ivy is that there is a, in the long term, they may quote unquote suffocate a tree or at least stop respiration and leaf out on a tree. But more so what I see is the weight of ivy, especially when it's raining and all those leaves are covered in water, the weight of all that just rips a tree down. A tree can survive with its weight plus some additional weight. It has a safety factor, but with the ivy, it far surpasses that and just pulls trees out. Another consideration on ivy is that on slopes, I found this study done, an unusual case of death, suffocation caused by leaves of Hedera helix in the Journal of Analytic Toxicology. So this journal was basically someone walking on it wasn't a shoreline slope, I don't think it was in our country, but they were walking over ivy and they fell in because the soil underneath had been eroded away. But it was it appeared that they were walking on a flat area, but they just fell right in. And this is kind of demonstrated in this photo where this is a site we worked at a long time ago where no one even knew there was a bulkhead here. Once we pulled all this off, this was like 6 or 8 feet thick of ivy. Once we pulled it off, then we could actually see the bulkhead. Up above, it looked kind of like, it just looked like a normal slope. But what had happened in reality was that all the water from the top of the slope was coming down underneath the ivy and scouring that soil away. So now they just have a 6 or 8 foot thick matrix of English ivy growing on top of their slope. What we commonly do with English ivy is herbicide. We do pull it sometimes as well, but wintertime application of herbicide on English ivy is pretty effective. Glyphosate doesn't damage the bark of trees. So like if we have trees or plants or shrubbery that is in a dormant season, not foliated, spraying glyphosate, if there's a little bit of glyphosate on that bark, it doesn't affect the tree or that shrub, but it will affect the English ivy. If the bark is photosynthetic, it would affect it like birch or quaking aspen. Triclopyr may affect the bark of woody plants, but you really have to get it wet. The other thing we do, and we've seen a few other times with ivy and some other plants like holly and laurel, is adding pelargonic acid, which is brand name is Scythe, just like a scythe being used in a grass field or an old hay field. Pelargonic acid is a burned down horticultural. It's like vinegar, very high intensity vinegar, and it can cut the wax cuticle on the surface of the English ivy plant and allow the herbicide to get in, to actually get absorbed into the plant. Very low, like 1 or 2% addition of high quality vinegar or pelargonic acid. And then another technique is this carpet roll. We see this a lot on slopes, and we do this a lot, or we recommend this a lot on slopes. The carpet roll is basically cutting ivy at the top and then just rolling it down in a roll. As you're rolling it, you're pulling the roots out, the superficial roots. You're just rolling it into a big pile. And at the end, it looks like a carpet roll. It works really good when you have gravity on your side. So you're pulling downhill. On flat areas, it's less effective. An important consideration here is just you want to cover this immediately. We don't always recommend pulling ivy because you just expose massive amounts of soil. When you apply herbicide to the ivy, you retain that surface mulch that you can plant into. But here you'd have to manage this exposed soil before the next rainy season. So ivy management can be difficult at times. Ivy is very salt tolerant. It can grow right up to the ordinary high water mark, but it is not very salt resistant. If it's in salt water, it will die. We've had a couple places that are, there's no good beach access. There's no good way to remove the ivy, basically. Like on this slope here, this ivy is draped down. This is in Port Townsend. This ivy was draped down about 10, 15 feet from the crest of the slope. We want to get that off of the crest. We want all that ivy gone, but pulling it up is going to be very difficult. Or rappelling down that and trying to push it up is massive, and there is no good beach access. So, in this situation, we're going to cut that off, or recommend cutting that off, laying it on the beach, potentially tying it in a bundle. What we've done before is with logs is tie them in wire rope and secure them to large woody debris, and just have a few nice wintertime tide cycles, and the ivy will die in place. The salt will just kill it. And you can see here on the right, this is ivy that fell from a landslide, and this new the ivy that's recently been exposed to the salt water is pretty quickly dying off. Of course, that should be, you should think about that. We don't want to put ivy on the beach loose, just big piles of it, and it just get washed away to the next site before it dies off. So maybe securing it temporarily is an option. So this is a good spot to talk about composting, and just debris removal. Some of our plants can be composted. Himalayan blackberry, Scotch broom, the laurel and the holly, butterfly bush. Blackberry does regenerate from stems. It can, but it's not very prevalent. I don't see it too often, and especially if you have a pile of blackberry, it's just not. It doesn't regenerate too quickly. The things to absolutely never ever compost or put in any kind of compost is bindweed, especially bindweed, knotweed, English ivy, poison hemlock. Those belong in a trash bag and at the dump. I heard about a situation where someone bagged up a bunch of bindweed in bags and then took it to the dump, and then one of their employees actually took it out of the bags and threw it in the compost. And communication is important. If it's in a bag, probably leave it in the bag. Some of these can be chipped. Blackberry and Scotch broom. Obviously, the English laurel and holly trees can be chipped. Chipping blackberry and chipping Scotch broom is not. I don't think it's a very easy task, and I probably wouldn't recommend it. But it can be done. So Falopia, this is knotweed. Don't mow it, don't cut it. Knotweed is a extremely fast growing plant that grows in extremely fast roots and very dense root networks, very energy rich new root networks. What I commonly see is I'll see somebody. We were working on the site in Everett where the right-of-way management team for the city of Everett, or the stormwater team, we told them many times not to mow it, but they kept mowing it, and we just kept seeing the stems propagate or germinate in a new area. So it'd move 10 feet over every single year from where they had mowed. The JK injector is a pretty common technique. This is what Snohomish County has a really big problem in their riparian, freshwater riparian streams and rivers with the knotweed. And this device was actually invented and is manufactured in Snohomish County. It's an injector that releases 1 ounce of herbicide into the hollow stem of a knotweed plant. So it's a very direct injection, and it works very efficiently. This is knotweed that's been cut. And I think what they were trying to do here was this bending operation. There is this option in very large swaths, like these are, half acres or acres of knotweed, where some of the noxious weed control boards will go in and bend the knotweed during just before flowering, bend it all, break it. They're basically breaking the stems. They do that for a couple of years, and it just weakens their ability to grow as quickly, and it reduces their ability to spread. So that is an option. On smaller isolated patches, it's probably not an effective solution. Bindweed is a pretty it's pretty invasive plant. I see this in some areas, and I see it in compost a lot. It's commonly mulch or compost or even topsoil brought in from a nursery or some facility that makes it and is not weed free. This was a site where they brought in compost, and the next season, or maybe it was that same season, this is what happened. Field bindweed is very fragile. The vines are wire-like. You can't really pull it like English ivy. I think the biggest thing with field bindweed is education, and letting your homeowners know and your employees and everyone else know that if you see this plant, you need to focus on it immediately and absolutely eliminate it. If it gets out of control, like in this area, you're going to be pulling this for years and years. And sometimes the best way to manage a very dense population is just going in and ripping up everything with an excavator, removing the topsoil, getting new topsoil, and replanting. The way that they grow like they encircle native plants. So trying to rip them off native plants is difficult, and you can't use herbicide because they're intertwined in natives. So no, focus on them before you focus on other plants. I'm not going to go too much into English holly or English laurel. These are larger invasive trees. Cutting them does not really do much. It just causes sprouting. What we see commonly is injection methods. So an EasyJect lance is a product you can buy, Easy, JECT, and it's just a lance that injects herbicide directly into the stem of the plant and kills it. The other option is a cut stump treatment, which is where you cut the stump of your plant, you cut it down, and then you come back and apply herbicide to the to that cut stump. In those situations would be a very concentrated herbicide. Two things to be just to remember in that situation is typically what I recommend is cutting down your holly and laurel, cleaning it up, getting everything out, leave a 2 or 3 foot tall stem, chip everything in, get it all out of there, clean up your work area, and then come back with your chainsaw and your herbicide. You need to apply the herbicide to a fresh cut within 60 seconds. If you wait longer than 60 seconds, you wait 5 minutes, or you cut down the trees, clean up, and then apply herbicide, it doesn't do anything. Coat it in those trees is forming very quickly, and it will stop the migration of that herbicide into those roots. So yeah, recut the stem, apply herbicide very quickly. Poison hemlock is a funny plant. We used to deadhead a lot of this, and I see a lot of people deadheading it, which is the idea of during seeding or flowering, you go in and cut the stems and remove the flowers so that they don't turn into seeds. I think if poison hemlock was a chemical that people purchased, you would have to have a hazmat suit on to touch it. It's very, very dangerous. I've had numerous people that I know have gotten sick just from breathing in the seeds. The seeds are very small, like poppy seed, or smaller than a poppy seed. So if you're manipulating the plant during seeding and you breathe it in, you can get pretty sick. Equally, touching them is it's just something that I don't want to be around. Sometimes I've seen homeowners cut it with a weed whacker with shorts on. That's not a good idea. They have potentially permanent scars on their legs. So just be very careful around poison hemlock. There is a native lookalike, wild carrot, Dracus carota. The way to tell the difference is poison hemlock typically has a pretty prominent, like this reddish maroon color discoloration on the stem, while the wild carrot does not. And the other way to tell the difference is that if you take a small, gentle whiff, a smell of wild carrot, it really smells like parsley. It smells good, carrot top. If you take just a gentle whiff of poison hemlock, it smells like something you do not want in your body. It smells very bad. All right, so a little bit about techniques and weeds and rehabilitation. So I said I would talk about herbicides. You know, I don't think anybody really likes to use herbicides. I don't like to use herbicides. Herbicides are a tool that we use in where we have limited resources. A question I asked, or I typically ask here, is how many people have their licensed, how many people are licensed applicators, and does anyone have an aquatics endorsement? So if you wanted to type that into the chat just so I could see if anybody is licensed, that'd be good. An interesting statistic is that noxious weeds account for less than 0.1% of global herbicide usage. So very little bit of herbicide, but I still think we should be it doesn't mean we should be complacent in using herbicide at all. And especially in these sensitive environments, the shorelines and wetlands and streams. A couple of key things is do not spray herbicide when your plant is flowering. We don't want to contaminate our pollinators. And second thing is to really think about how you can reduce the quantity of herbicide in just all of your situations. Like when we, like the blackberry story about cutting blackberry down all the way and then spraying the regrowth. In that framework, we can reduce the amount of herbicide by, maybe 80%. And it still reaches the same goal. So a couple of little techniques that we've used for a long time and recommended. So the native plant release. Native plant release is basically working on a site with a mixed population of invasive plants and native plants. You can see here on the right, we have this nice little sword fern, a couple of them, and a Indian plum, maybe over here, that are being encroached on by our English ivy. There are other places on this site that it was just a monoculture of English ivy, just 100% English ivy everywhere. What I recommend is focusing on these established native plants, releasing them from their releasing the invasives from them and rehabilitating that area before working on the large monocultures. This will give time to identify techniques and what works on that site, not techniques, but what plants work on that site. And I think that encouraging or existing established native plants to grow and potentially produce more is more beneficial than installing many new ones. So native plant release, we usually go in and remove 2 or 3 or 4 feet from our native plants, radially outward, potentially mulch that area, reinstall that area with native plants, and then come back in a year and do it again, maybe 3 or 4 feet additionally around that, and just keep focusing on those, releasing those natives and allowing them to grow. And then when this is done, coming back to work on the monocultures. Excuse me. So the vertical strips is another common technique in steep slopes predominantly. I'm sure, you know, most landscapers know how to rappel. If you're a tree service, I'm sure you know how to rappel. So rappelling off the crest of a slope downward in kind of a vertical swath where you can either hand remove invasive species or you know, apply herbicide with the backpack on. That's it's an uncomfortable technique, but it works pretty efficiently. You know, usually this is with English ivy, and you're kind of rolling carpets downward down the swath. It's more beneficial, I think, to use these vertical swaths than horizontal swaths. Both, you know, applicably, it makes sense because walking horizontally across the slope, you're just going to damage the slope. But then also what we're doing with those horizontal swaths is just creating areas where water can kind of sit for longer in like tiers across the slope. If we're doing this, we want to put down geotextile fabric or whatnot. So this fabric here is a coir mesh. So it's not a continuous carpet, but it's a mesh network of coir. Coir is coconut shell. It's just recycled coconut shells. You can also buy this material in, there's a couple of different methods. There's jute, and there's some that are made of kind of consolidated straw. But both of those, they really degrade quickly. In our environment, coir lasts a good 3 to 4 years. One thing that I think is important when rappelling down slopes, I've heard this from a few different people, is that you know, people perceive it to be an easy thing. They don't get really, you're not as prepared as you are climbing a tree or ascending a tree, and you rappel without really having a technique to ascend. You know, you just anticipate getting to the beach and walking back. But there have been times where I've seen people rappelling, you know, with a figure 8, where they can't really ascend well, and they actually realize that the slope isn't where, or the beach isn't where they thought it was. It's an extra 30 feet down, and now they have to finagle something to actually get down to the beach all the way. So just think about both up and down. So sheet mulching, lawn removal. This was not a shoreline site, but nonetheless, this was a site that all the grass was removed. They wanted to replant native plants, basically a lawn to native plant conversion. You know, these are great options. It's herbicide free. I think this was all English ivy, or there's some invasive plant, but it was all dug out with a small excavator, mulched out. A common tactic in sheet mulching historically has been the use of cardboard. So you put down, you cut your lawn out, or you mow it down as low as you possibly can. Lay down cardboard, lay down newspaper, maybe, and then put down a thick layer of wood chip or hog fuel on top of that. That's not too good of an idea. I've seen a lot of people put down cardboard with tape still on it, you know, but beyond that, you know, cardboard is generated these days with PFAS, different forever chemicals. Newspaper has chemicals in it that we do not want in our soils. Beyond the pollutant aspect, the layer of cardboard creates this anaerobic environment in our soil. It doesn't allow oxygen to penetrate into the soil, deprives it of oxygen. You know, something I hear about often is we want to suffocate out the plants. Let's suffocate out our invasive plants, but you know, suffocating our plants is really not, we want to kill them, but we don't want to suffocate that soil. That soil is living, it's breathing. We don't want to do something that suffocates that soil. If cardboard is used on wet, poorly draining soils, it just creates really anaerobic environments, really makes it much worse of an issue. Our mulch should be maybe 12 inches deep, 8 to 12 inches deep, coarse wood. not sawdust. I've seen people put down sawdust in this capacity. We want coarse debris, coarse wood chip and hog fuel, not sawdust. Something that's been talked about in the past is nitrogen immobilization of soils where there's been mulch applied. I hope everyone here has heard of Dr. Linda Chalker-Scott. She's like Mythbusters, but for plants. The idea that wood chip on the top of soils immobilizes nitrogen and then stops weed production or any kind of plant production on the surface of that soil isn't really accurate. There may be a very, very thin layer of nitrogen immobilization beneath the mulch, but it's extremely thin. As I mentioned earlier, if you mulch in the wood, that's a whole different thing. How much to remove? I think this is it's very site specific. On this site, we're looking at two different sites. On this one on the left, we're looking at a site that has far less of a grade. There's large conifers growing, which means that there's less recent slides. Here on the right, we have young deciduous trees growing, indicating a more recent potential slide. We have pretty vertical area. Really think about the grade of the site and how long it's been since there's been any kind of movement or erosion. The one on the right, I probably wouldn't do any quicker than a 4 or 5 year type of thing. This is a long-term investment, not a single summer job. The one on the left, maybe over the course of 1 or 2 years, that could be done. But typically speaking, you want to separate this out to a good 3 or 4 or 5 years. Going into replanting, I'm going to speed it up a little bit here, but going into replanting, this is sometimes the expectation that homeowners have, right? You say native plants. Let's put in some native plants, and they think that this is what the house is going to look like. That's not true, right? Most, we want to put our native plants in areas that are still allow the homeowner to use their property, and put in native plants that are maybe somewhat manageable. Here we have a kind of formal garden where we still have some trees, have some very managed salal. This isn't exactly what we want in all of our sites, but if this is what we get, it's better than nothing. Like if the other option was this being a lawn, I would take this. Some people do like to hedge their native plants. Some native plants work well with that. Snowberry does very well. Nootka Rose does very well. Salal does pretty well with hedging. So if people do want to keep things manicured, you could kind of emphasize the fact that let's put in some natives, but also you can keep them a little maintained, quote unquote. So plant tubes. This is an interesting subject, and a lot of I don't know if Austin is still here with us, but in a lot of SMPs that I read, shoreline management plans and programs, there's this common requirement to replant. If you remove a tree, replant 3 trees, but they want 3 5-gallon trees, very large specimens, potentially bagged in burlap trees on this slope, or in that size. And I think that's generally very impractical. My recommendation is always doing bare root plants, 1 gallon, and better than that is just many plant tubes. These little 10 cubic inch tubes. If we're installing 1 gallon plants on very steep slopes, at that point we're just eroding soil and potentially causing erosion issues. The idea of putting up and down a 5-gallon plant or larger on a slope, the hole that you have to dig for that is quite large, and equally native, or not native plants, but the larger your plant, the more water it's going to require in summertime. So if we put in these small plants, they're going to require much less water every summer. As they continue to develop and grow, they'll need more, but they'll have more roots. Our larger plants need an immediate amount of water. So if you put in 5-gallon plants, they're going to need irrigation. So when I do have a project where the county or city is requiring, a 5-gallon plant installed on a steep slope, I most always will say, let's do it this way instead. And most always that's what happens. So they take that into consideration often. These are nice because you can just install them with a dibble bar or a piece of rebar without disturbing much soil. We plant a very large amount of them, maybe triple the amount you would typically use, because they have a high mortality. But they're cheap, so it's fine. Live stakes. Live stakes are, a branch cut off of a willow or cottonwood or a snowberry potentially that's inserted into the ground. My recommendations for live stakes is don't purchase them. If you have to purchase them somewhere and they're refrigerated and they're shipped to you, and then you have to wait a week before you install them, you get very low success. They really need to be installed within 1 to 2 days. So harvest locally and install them, very soon. If you can't install them the same day or the next day, they need to be in water and or under freezing temperatures or near freezing. Refrigerated could work as well. But again, if you refrigerate, they just have very low efficacy in their growth. Typically, these are maybe 1/2 inch to 1.5, 2 inches. The length of them really depends on how far you can insert them into the soil. You would not want more than 1/2. And between 1/2 and 1/3 of the stick protruding out of the soil. Any more than that, the stick will desiccate too quickly. So typically, what this you can see here, this is a very long stick. We inserted it into the ground as far as we could, and then we cut off, up to about 18 inches. And all of these, we did a project in the Hoh River where we put in, I don't know, it's like maybe 6,000 of these stakes over the course of a couple of years. And yeah, most of these are a good 2 to 3 feet in the ground. And what we cut off, we just reuse in another location. All the leaves should be removed. So here's a little example of one that we saw. This was years ago, but just a quick discussion as to what's going on here. All of these were dead the next year. What happened is they might have been inserted a foot, maybe even 2 feet, but they had 6 feet of stem above them, and that whole stem leafed out. So there's leaves like all across the stem, and we know that when leaves are constantly wicking moisture out of the stem, if there's no roots to sustain that moisture, then the stem dries up and dies. There's also this walkway that was you can see they walked up and down the slope, which is eroded soil, which could have been cleaned up a little bit. Yeah, make sure your live stakes are short, or not short, but they don't stick out of the ground much at all, and there's no leaves. So coir fabric, this is so on the right here, we can see this is the continuous style. This is the jute fabric, I believe, or maybe this is the straw. So this is continuous straw. On the left here, we have coir netting erosion control fabric. Be careful using the continuous blankets. Oftentimes they're secured with plastic. So not really a good solution on a shoreline environment. The netting is not really secured with plastic often. These products are usable and they're effective, but they do require significant kind of preparation. If our crest, we're going there, I guess we're going to the next, but if our crest of our slope is not, they need to be in contact with the soil at all times. If there's like an undulation in the soil, We need to kind of fix that undulation or maybe rake it out. On landslides and just natural erosion areas, they can be really difficult to install properly. You know, these are designed for highways and engineered slopes, 2-to-1 slope, 3-to-1 slope, where you can just roll it down your hill. So here on the left, you can see this crest had, this was a landslide, but the crest had been out here somewhere. And there was an overhang. We can't install the erosion control fabric, you know, above an overhang. So we basically had to reshape the crest here. So we dug this out, placed all the soil down the hills, maybe a foot or 18 inches of soil, maybe. But we had to make that an area that could, you know, we could layer the erosion control fabric back over. And that's called crest reshaping. So here's one that in Port Townsend, I just saw this a couple of weeks ago. This was a huge overhang with a lot of ivy. This is the same site with all that ivy on it. This is maybe beyond what crest reshaping should be, but it's an idea of, you know, if you have an overhang like this and you want to put geotextile or geotech fabric over it, you can't do it on this site. You would have to bring this all the way back to the slope face so that your erosion control fabric is in contact with your soil. I think I'm running a little behind. I'm not going to plastic sheets. These are temporary products that are really like emergency use. If you have a landslide in the middle of winter and you need to quickly dewater or reduce precipitation onto that landslide, plastic sheeting is pretty efficient. It's very hard to install. Usually you're going to use sandbags tied to a rope to hold it all down. Hydro seeding is interesting. I see hydro seeding done occasionally. I think it's a useful technique on landslides where there's a lot of erosion. The seeds used in hydro seeding, there's a lot of native seeds. The shrubs don't work that well. Elderberry works pretty well. Lupinus works well. What I commonly see with lupin seeds is that be very careful not to get Lupinus arborea or boreas. That's commonly sold as just lupin, but that's from California and it's invasive. So it's not something we want to put into seed mixes. The other things that work well are unfortunately red alder. Red alder works great for hydro seeding, but that's probably the last thing people want on the review. If you are hydro seeding, this product is called a bonded fiber matrix, BFM. When it dries, it is harder than and more erosive resistant than coir netting. So once it dries, it is very effective at stopping erosion. All right, so I'm running a little behind. Let me just kind of, I don't see pistol butted trees too often in Washington State. This middle one, this was from Michigan. You see them out there pretty well. This is in Snohomish County. This is a soil creep in Snohomish County. And this one was in Forks. These are one of those things that if you see this, this is an indicator of slope instability. If you see things like this, it's kind of hard to discern, but bent trees, you can see that bend in there. And these ones, this almost looks like a disease epicenter, but this is soil movement, trees just kind of leaning into each other in different directions. These are areas that you might want to, just inquire with a geotechnical person or a geologist to figure out if your work is going to accelerate the soil creep or not. Soil creep is just very slow movement of large amounts of soil that trees react to by bending. So this is a landslide. This was in Austin probably knows about this. This is the Noble Cliff landslide in Whidbey Island. Happened a couple years ago. They didn't really have much buffer, native plant buffer between their lawn and their slope. Their crest of their slope was right here. So this whole area is just grass and then crest of slope. The geotechnical report indicated that the hydrology was one of the influencers in this landslide. So what do? This is another homeowner on Beamerage Island. Very little room between the slope crest and their house. They equally had no room to move their house. Sorry, there's the slope crest. There's a fence. In these conditions or in these sites, this person even had a fence here, and they had done some funny little planting here and here. My first question to them was, do you use this space at all? Like there's even a fence there. And I think they even mowed it. I think they had the landscapers mow at least a portion of this. And my question was, how much of that do you use? And it was obviously none because there's a fence there. But even when there's not a fence, like just because you buy a home and there's a giant lawn doesn't mean that you should keep that lawn forever. So I really like to ask owners how much lawn they actually use in a given year. In this area, this person replanted this entire area and even a little bit on the inside of their fence. And the main influencers here were just surface water flowing from the grass and from their roof this way towards the slope. I'm not gonna talk about that, sod removal. Here's a landslide that Evan sent me, Evan Sussman. This was an interesting one. You can see, I don't know if I have this in the right order, but you can see here this large rill forming. So a rill is just, channelized water. It's water that's channelizing. So originating from somewhere up here, coming down and causing this large rill. This is another photo of it. Another one. So I might go back for a second, but one of the things that Evan and I talked about was, and he just sent me, we just talked about it after I asked him for some interesting photos, was that there was this depression kind of nearby the house that may have held stormwater. I believe there might have even been a drain there. So there was a drain that may not have been flowing as well as it should have, or outletting as well as it should have. And then further, I believe the homeowner installed some soil into the bluff. So in this area, they kind of filled in, and that's probably some of what we're seeing in here, is they filled this area in with soil that they just brought in. So there's two kind of massive things there. One is the drainage, the drain, just that amount of water having no place to go. And then two is the infill of soil. I haven't talked about that at all, but when you add soil to a slope, when you have different compositions of soil, they never form a matrix. They never kind of combine themselves, and their shear strength is very minimal. There's no shear strength. So when you add soil to slopes, to native soil, you most commonly see all of that fill just erode down over time, either acutely or chronically. Acutely in this scenario. One of the things I think about, Evan and I talked about on this, is just that, it's important to, even if your client has like this one mission, right? They have the mission of, let's plant some stuff on my slope. Let's get rid of some weeds. Let's put some mulch out. They have this mission. When you get to the site, it's useful to you and them to figure out, what else might be happening here. And what else might be happening is, their unmanaged stormwater. So then just, mentioning that and going off in that direction. All right, I think I only have a couple more small slides. These are live stakes on a giant slide that I could talk about it more if wanted, but I think I've overdone my time.
Yeah, we've got quite a few questions. I think it would be good to answer these and then maybe potentially take a quick break.
Yeah.
So first question, do you have any general thoughts on vinegar applications versus herbicide to preserve hydrologic purity?
I think vinegar works in some scenarios. Vinegar would be a burn down product, which means it kills the foliage of a plant, but not the roots. So you'd have to apply it continuously on a regenerative plant, every season, just over and over and over. And in that process, I would be concerned about just pH changes in the soil based on doing that over the course of 10 years, just because it doesn't translocate into the roots itself. So it's a good way to kill the foliage of a weed, but maybe not so much the roots.
Great. Are herbicides effective with field bindweed if it's not on plants, for example, on flat ground?
Yes, it is effective, and you don't need much. It's such a gentle plant that herbicide, you could use I believe we've used maybe and in King County BMPs, it's like a 1.5 to 2% mix of triclopyr and glyphosate. So a pretty limited amount can kill it on flat terrain. I recommend multiple treatments because the roots just go down for feet. So even if if the plant is translocating that chemical, the plant may basically abscise a portion of that root before it reaches the bottom, and it's going to resprout. So multiple treatments, but yes.
The next question is about the connection between soils and invasive plant management. Have you seen any studies researching soil modification or soil improvement and management of invasive plants?
Yeah. Let me think. I think certainly in some respect, many of these invasive plants are growing in highly disturbed environments. So there was an initial disturbance that caused that outbreak in most areas. So let me see. I guess I don't know of any research specifically on that. I know there has been research on how Scotch broom is a nitrogen fixing plant, and it's very well established in many forest plots. But looking at how it affected nitrogen availability in forested areas after development, like thinking about, is control really necessary if it's fixing nitrogen in the soils of these forested areas and eventually going to be shaded out by larger Doug firs or larger conifers that are the harvest trees. And some of those studies, and in other studies I've seen where the Scotch broom is working to reduce germination and reduce growth of the harvest trees, so the Doug firs and whatnot, so they never get really big enough to shade out the Scotch broom. But that's it. I haven't seen any other real. I've seen some soil things related to disease, but not necessarily invasive plants.
Okay. Next question, can you tell me more about plant tubes? Are you putting them together with bare rootstock?
Yeah, plant tubes are they're typically only found at like native plant growers. You know, you can't find them in a nursery. But there's NATS up in British Columbia, and then there's a site in Oregon that sells many, and then I believe the Washington Association of Conservation Districts can occasionally has them. WACD out in Bow. They're you know, my favor towards them is that they're easily installable. You can install them while rappelling down a slope with your plant bags on your sides. And I really prefer, when we do reinstall plants, I prefer young stock, young plant that is able to, you know, that hasn't hybridized itself. Hybridized is the wrong word, but hasn't adapted itself to a nursery growing condition, and instead kind of just spends all of its time. You know, those plants are barely a year old. They're very young. So they're growing in that slope from a very young age and able to adapt to those conditions quickly. Also, young plants can adapt typically better than you know, older specimens. So that's why I like to do them. And I do use bare rootstock. You know, bare roots are nice because on a steep slope, again, you don't want to dig holes on a, you know, on a grade that's 45 or 50%, or really above, you know, 45% or 40%. But if you just take your shovel and insert it into the ground and kind of pull back and forth and get that notch opened up, you can scoot in your bare root pretty well, without digging a big hole. So I think intermixed with those is a good idea.
Great. Lisa also put in the chat that gnats will ship to the US and put a link in there for anybody who's interested. What kind of erosion resistant techniques can be used for heavy rain events, knowing that they are becoming more consistent and accompanied by heavy winds, excluding planting shorter plants?
So on a steep environment, really we're just looking at well, let's say not super steep, but maybe at a less than 30% grade or whatnot. You know, grass is what's commonly used. We use a lot of grass in different areas for erosion control. Grass is not going to provide your many of your hydraulic functions, but it does slow down surface water. Mulch, you know, thin layers of wood chip mulch, similar to how we don't want to just put down grass clippings or very thick piles of fine debris on slopes. We also don't want to put 3 or 4, 5 inches thick mulch on a slope, but 1 or 2 inches of mulch is a good technique. Maybe accompanied with erosion control logs installed horizontally to break up that velocity of water down the hill. The heavy winds, that is a thing I'm seeing. You know, the erosion control fabrics, the coir netting and whatnot, unless that thing is secured to the ground very well, when you get high winds hitting it from the side or straight on, it just flaps in the wind. That flapping itself causes erosion, and then soon enough, it's just blowing like a flag in the wind, and not really doing anything. So mulch, grass, best thing is plants or shrubs, but
Great. Last question. If you want to kill an invasive plant before it pollinates, then could you apply the vinegar first and then the herbicide, or dig up the plant as long as you killed the seeds and rhizomes first?
yeah, I think if you I think if you dig it up, then no vinegar and no herbicide. You know, if your plan is to just dig it up, by hand or with an excavator, and I wouldn't use herbicide or vinegar, or anything. So I guess that killing the seeds, right? So killing the seeds first. You know, I think that is with Scotch broom, that's a big deal, and also poison hemlock. If for Scotch broom and poison hemlock, if we are extracting that plant after it's seeded out, sometimes what we're going to do is come in and cut off the seed heads, put them into trash bags first, and then come in with like a flail mower and flail everything down once the seeds are gone. Equally with chipping, you know, sometimes what I recommend is if you chip a Scotch broom with the seed heads intact, those seed heads just pass right through the chipper. Some of them I'm sure get demolished, but many of them pass right through, and then in your chip pile, you'll just see this Scotch broom next year. So deadheading prior to pulling them and chipping them, or deadheading prior to cutting them all down or digging them up, it could be useful, especially for Scotch broom. You know, I think Scotch broom, managing just the seed population of Scotch broom is the biggest part of the battle. Like if you can just stop those plants from seeding, even just by hand every year, you know, that stops production of thousands of these seeds that persist for 100 years.
Wow. Okay, I don't see any more questions, so why don't
Actually,
we take a,
We got
oh,
one, looks like Kathy maybe has a question. She wants
oh,
to,
okay.
Kathy, go ahead and ask, you can unmute. Oops, sorry. I hate making this difficult for you. I think I overclicked.
Got it. Okay, got it. Thank you. My question, so I don't, I'm sure you've heard this a lot. I don't like using glyphosate, and I have all the invasives. Well, not knotweed, but I heard when you were talking about injecting the knotweed, I was thinking about, and I have done this before, it's been effective. I just want to get your feedback on it. So instead of using like the applying, you know, like the glyphosate or something that I have, and this is just on smaller areas, like in a residential yard, is if I see like the ivy coming in, or, you know, bindweed, which I cringe at, I will just cut one root, like on a hot day, right? And leave it sit for a couple hours. And then I will put it just in the bottle of, you know, like glyphosate, and then it'll suck it up, and it is super effective at killing that root right away. But I'm just wondering, okay, so feedback on that, and then also how you think the vinegar might work as well with that method.
Yeah, that's interesting. So that was like with bindweed and ivy that you.
Yeah, it works. I haven't actually done it with bindweed. Of course, it has creeped into the yard where I'm working on in the last year from the neighbors, and you know, nobody lives there, so it's just like going crazy. And I'm like, oh, I tried this with ivy before, and it works so well with ivy. I just put, like, it was wrapped around a tree, a small tree, you know, starting, and I did it on a hot, you know, you got to do it when the root is going to suck it up. And so I just cut that root. I left it for like a couple hours, and then I just put it in, I think it was like a container of Roundup or something, and it just sucked it all in. I mean, it was just like, you know, an inch maybe in a jar. And then it killed all the roots around that tree. And I was like, oh, that does work. So I'm just wondering about the toxicity of this, because I'm trying to eliminate just everything going into the water table, you know? And I'm just wondering, again, feedback on that, because I don't have all of the varied education and knowledge of people that are here.
Yeah.
So.
Yeah, I think that, you know, that makes sense. You know, that's a you're kind of going right to the source, right? Like That's exactly where you're not even waiting for translocation of the herbicide.
No,
Leaves to
I'm
the
in a hurry,
roots.
right? I just wanted to get rid of the stuff I don't like and try not to harm anything.
You know, so my fear with that is less so environmental and more so, I guess, like just my fear would be having a container exposure, right? Risk exposure. So having a container open, sitting out there and like an animal or it's, you know, something just like touching it and then it's spilling.
Yeah,
That would be my concern because, you know, with topical treatments, we're looking at like it's pretty low, like right, we're using a typical topical treatment is going to be 4% glyphosate with water and then 2% triclopyr. It's a pretty common formula.
okay.
So like very low percentages, and if that spilled, it's like it's really not that crazy of a thing. But then if if you spill a, or if a container of glyphosate is spilled, that's just a more of a
Right.
exposure to concentrated formula. It's the concentrated stuff that we're
Yeah. So do you think that it would be like if I did the mixture, so how I do it is, I mean, I'm aware of what you're like, that was my biggest concern doing it. I'm like, okay, how can I do this? So I just get like a container, and with the like a pop bottle size screw lid, and then I just drill a hole in it and then I prop it up and I just put the root in there so it doesn't spill. And it's only in there for like, half a day or something, and then I pick it up. But if I did the mixture, would it be as effective, the proper mixture?
I think so.
Okay.
I think it works on leaves, so it should be fine on roots too.
Okay. Cool.
And I don't know about the vinegar. You know, it might work on the leaves, or sorry, it might work on the roots. It might not. I don't know.
Because that's mostly for the foliage then. Yeah, like you said. And that's been my experience.
Yeah, yeah.
Thank you.
Again, while John's getting set up here again, from the shore-friendly point of view and us working with shoreline landowners, drainage management on bluffs is really becoming a key part of our processes and our engagement with landowners. Trying to get them to understand that proper drainage management is really going to be one of the best things they can do in order to protect their homes from erosion. All right, take it away, John.
All right, welcome back. So yeah, drainage management on bluffs. So as a consultant, I've worked on maybe 100 or so, a little over 100 of these on the biological consulting side and design side, and we've installed numerous of them as well. So the need for drainage. So we come in here, cut down all the trees, compact the soil, install hardened surfaces. Now we need to manage the water that typically infiltrated into the soil. I think this is a really important kind of, just for the business owners out there, this is a niche that is not being met very well. This sort of drainage installation on steep slopes. I see a lot of contractors doing it in upland environments and near slopes, but once they get to the slope, it's just not it doesn't happen as they're not installed as they should be. There's a lot of really big companies who work in this field, but when you have a drainage pipe for like Miss Helen's house, just a small residential property, these big companies obviously don't want to come out and do that. They're working for municipalities and larger institutions. So these drainage plans, as Austin mentioned, I believe he mentioned it in the shoreline, because it's a shoreline environment. These are appurtenant structures that require permits, engineering, geotechnical, and biological consulting before the installation. The engineering and the geotechnical look over the engineering looks at how the pipe functions and if its capacity is large enough. The geotechnical looks at anchoring on the steep slope, and the biological looks at how the drainage affects the shoreline biology. So water management goals. Typically on a shoreline environment, what we're really looking at doing, well, this goes beyond shoreline, but specifically to this, what we're looking at doing is managing sheet flow So the water that's hits a hardened surface and flows, managing that before it hits the crest of a slope and begins to go down. Capture stormwater from hardened surfaces, capture groundwater potentially, and then convey or tightline all of that water, that stormwater and groundwater, to a safe infiltration area away from the slope. So managing sheet flow, we talked about many options for managing sheet flow using vegetation, reducing velocity. There's obviously built ways to do that. There we go. These are some of the options we have that are non-vegetative. Channel drain. Here we're looking at a catch basin, but all these instruments basically are capturing water that would otherwise flow into another environment, potentially causing erosion. One of these pretty common techniques is a channel drain. Channel drains are commonly seen on that intersection between a driveway and your parking garage at your house. Where's my pointer? So yeah, channel drain right here. This captures water coming from down up the driveway and moves it in this direction in a pipe. This is a nifty one. This one collects that water, that surface runoff from the cement walkway and inputs it into a rain garden. The second element of this is just, well, this is, I guess, more water capturing. Once we capture our water, we want to put it into a pipe. And when I say capture water, we're really looking at, anything producing water. So pipes, gutters, French drains, curtain drains, anything that we can collect water from. And then lastly, we transport that and release it. In stormwater jargon, we usually use the word conveyance. So we convey that water into another location. So here you're looking at a pipe. This is an HDPE solid wall HDPE pipe that's coming from the top of the hill. And we'll talk more about that pipe, but this is the general look coming down a steep slope. One of the important things to talk about in this, I think, is the relation to long-term versus short-term. These, anyone can go to Home Depot and buy a 100-foot coil of corrugated black pipe that costs $100. You duct tape it onto your pipe, throw it down the hill. They're good to go for a couple of years. This pipe here on the left, this installation may cost $20,000. It's a large installation, but it's going to last for 20 or 30 or 40 years. It's like putting on a new roof of your house or doing an add-on. It's a very, it's an investment of the owner's money. And again, it can last a significant amount of time. What I see most commonly is those black corrugated pipes ending up on the beach, this beach trash. What happens on these black corrugated pipes is, typically they're sitting on the surface of the soil or sitting on the surface of plants. They're not well intertwined and they're not buried. They shouldn't be buried, but nonetheless, in the summertime, they're very light. There's no water passing through them. We get high winds, and it just picks these pipes up and float, pushes them up and down on the slope. Excuse me. And that process of getting kind of flown around in the wind breaks the pipes. Equally, just the UV exposure degrades these pipes pretty quickly. UV exposure does not degrade solid wall HDPE very well, but the sunlight does cause a lot of issues. So this is pretty commonly what's used in municipal applications and homeowner applications, HOAs and other multifamily units for managing many things more than water and stormwater. This could be pressurized water, could be gas, could be stormwater, could be some other things. We call this an HDPE fusion tube or solid wall HDPE. There are multiple thicknesses. So thickness of your shell, basically. A pretty common thickness in residential applications is SDR 17. They make thicker and they make thinner. This one on the right is a 4-inch. Yeah, this is a 4 or 6-inch pipe with a handheld thermofusion welder, and the one on the left is I believe a 24-inch pipe with a a mobile thermofusion welder. Basically, what's going on here is there's this heat plate here, and the heat plate is right here on this one. That heats up each side of the pipe. There's a certain time you want to heat up that pipe at a certain temperature, depending on the thickness and the size of the pipe. And then the machines push that together, and they become welded together. You equally have to push them and hold them together for a certain amount of time. Prior to doing all of that, you can see this cutting wheel here. Basically, the pipe itself needs to be extremely how do you say it? Each end of the pipe needs to connect flush. So you use the cutting wheel to make sure they really connect really well. Usually you're going to apply alcohol or some sort of alcohol to the rim of these pipes. If you touch them with your fingertips and then try to weld, the oil from your fingertips can reduce the bond that they have. And pretty cool that the tensile strength of the bond is actually higher than the tensile strength of the pipe, which is kind of crazy. And this is called butt welding, so thermofusion butt welding. Something that I think is important on shoreline property owners is just understanding where your pipes are. This is a common request for homeowners. I've seen sites that have 4 or 5 or 6 different black corrugated pipes and maybe a couple of PVC pipes and some HDPE coming down their hill and outputting onto the beach, and they have no idea where any of them began or what they're doing or how, their pathway on their property. So these are fairly inexpensive, pieces of equipment, a locating device. There's many varieties from Leica to there's a local company in Paulsbo that makes them. Prototech makes locating devices. I'll put the name in the chat, but they're local out of Paulsbo, have great devices. This is a electrical fish tape. You can basically you charge the fish tape using your box here, and then you insert that into a pipe, and you can locate wherever that pipe is. Generally, there could be some issues, but really nice way to find out where the pipes are and see if there's leaks, or just give a small map like this to a homeowner so they know in the future where they are. Oh, they also make another thing on this. They make ones that are flushable. It's kind of nice if just randomly, if you have to put one down a pipe or put one down a thing that you can't access, you can flush it down or wash it down, and you can retrieve that the frequency from the sonde is the flushable device. So a couple of things here that I see in the field. This is a 5-year-old curtain drain. So this is, again, a contractor went in and put in the curtain drain. I don't know if you can tell, but yeah, curtain drains don't work when there's soil in them. This is completely filled with soil. just installed a couple years ago. Sediment socks like this, or pipe socks, are commonly used to stop soil movement into pipes. And typically you would have additional products kind of separating the soil from the interior of your pipe. I thought this was an interesting one. There's two simple things that I kind of see done wrong often, and one is the curtain drain holes pointed upward rather than downward. You can imagine if you have a trench, where am I? If you have a little trench and you have a pipe in there, and the only way that, if water is filling up your trench, it has to fill up to 4 inches to begin entering into the pipe. Water between 0 and 4 inches is just sitting in the trench. You put your curtain drain pipe in upside down so that water can percolate upwards. And if your curtain drain is at a grade, 1% grade, it's going to move through the pipe quicker than it's able to infiltrate downward. So it's collected in the pipe and moving. The one on the right here is, I think, interesting. This is just like before, when you have a sediment sock around your pipe, you also need some sort of woven or non-woven geotech fabric, which allows water to pass through the membrane, but not soil. You would insert that into your French drain as well. And here they inserted plastic, which kind of eliminates the whole, idea of collecting groundwater from a pipe. The water is going to hit the plastic and just go no further. So all of these elements, the goal here is just try to collect groundwater and move it to another location. Roots. Roots interact with pipes pretty frequently. Roots don't find pipes. They don't find water in pipes. They can't break, they can break a pipe if a hole already exists, but you're never going to have a tree root just somehow sense water and go to it and break a pipe to get that water. If you see roots in a pipe, it means there's a hole in that pipe somewhere else. Quick talk on the engineering. This is another thing that I think is important to consider. I said that I've done about 100 of these, and I've seen many, many, many plans, engineering plans, and they're all vastly different, like wildly different. And some of them are missing like crucial things that I've known to be crucial. I'm not an engineer, but I've worked with them enough to know when something should be there and something should not be. So I think that these engineering plans really should just be considered by a person who does the work with their boots on the ground. It really needs someone to look at that and just provide that boots on the ground experience to see if it makes sense or not. Sometimes they just don't make sense, and you have to go back to the engineer and ask questions as to why they're omitted something or they're adding something new. We've seen a lot of these pipes have this T diffuser. Where am I? T diffuser, like here. The reason we do that is to control the speed of our outfall. We have here this uncontained outfall. This is not a shoreline slope, but obviously that's going to cause a lot of erosion. Here they kind of have a riprap outfall, slowing down. The water here theoretically slows down due to all the rock. And here they just have this is a black corrugated pipe, just going straight down with no reduction in velocity. So it just comes right out, hits the beach. The geotech I worked on this said that this was caused by this was caused somehow by just that flow of that water. It might have been pushed back during high tides and just caused that erosion in that cave. Yeah, so that's why on these outfall pipes, on these tight lines, we usually put on this T diffuser with holes in it. The holes are only faced outward. we don't want holes facing towards the slope, only outward, but those holes just reduce the speed at which that water comes out of that pipe. The reason for all of that is just beach coarsening. If we have a lot of water flushing out of these pipes, the beach sediment, the fine beach sediment that our forage fish typically live in and breed in, will be flushed away, into the ocean, and we'll only have our coarse sediment left over, like this sediment here. This is what we want to keep on the beach, and if we just keep flushing away, it's not going to work. It's not going to stay there. This, I guess the reason this sand is still here is this is a pretty active feeder bluff, so it's constantly getting new sediment pushed down. Couple of small things that I think are important to point out. These are two things that engineers sent me to review on biological plans. Both were denied. On this one, they wanted the outfall. This is the pipe. This is the T diffuser. They wanted riprap installed at the bottom, like in that prior photograph. This one, this was in Port Townsend, and the beach itself was a rock beach. It was just completely rocks bigger than the size of the rocks they wanted on the beach. And when I called the engineer and asked him about this, he said he had never been to the site, and he had just, got this diagram from another location. So again, really good point to just talk to the engineers and see what they're thinking, because we don't want to put more rock on the beach, nor do we want to put more PVC pipe on the beach. This was basically a splash pad to reduce velocity, installing PVC and soil anchors on the beach at the basically at the high water mark. This was eventually denied, but just random things that you see in plans. Another one, trench dam, bluff pillow. This is basically where you have a trench where your pipe is daylighting out of your upland environment. So you have a slope, so you have a flat surface in a 4-inch wide trench. And where that trench daylights onto the slope, how do you contain that sediment that you're going to backfill into that trench? It's usually done with a slope pillow. And that's just sandbags basically in this area replanted. I've only seen this in a handful of plans, even though I've been told by numerous geologists that this is very important. So nowadays when I see plans, I try to make sure this is in there. So there's a landslide. A couple of stories. This homeowner bought this piece of property 5 years ago. Had anticipated replacing the tight line or replacing the drainage, and instead prioritized other things in the house. Within a couple of years, they had a big landslide because the water system broke. So I think it's important to just, if I had talked to that owner 5 years ago, I would have just really articulated the importance in taking care of this before, repainting the house or doing some other cosmetic improvements. Like, this is a very important task. His pipe was similar to this client's pipe, where it was actually duct taped on by another general contractor. This is a property in Bainbridge Island where a curtain drain was installed by a general contractor. Really nice curtain drain. Everything was installed properly. It looked good. But once they got to the crest of the slope, their pipe that was about a foot buried deep, they just duct taped a black corrugated pipe to their PVC and put it down the hill. And she had a landslide that same winter when the duct tape was pulled off of that PVC pipe. You can imagine the water flowing down these black corrugated pipes there's a lot of movement in that pipe from that water. All right, recap. So the drainage has to be engineered. Review the engineering plans as best as you can. I think the practical knowledge from general contractors is really important. Also review what the biologist says. You know, sometimes biologists have requirements or provisions in their plans that are just, you know, need to make sure that that's gonna work. And last one is don't use duct tape. And that's it.
Wow, John, that was incredible. That was a whirlwind of information where you've been giving people and, you know, a really good look at, you know, kind of the do's and don'ts and the best practices. And can't thank you enough. We're gonna hold off if there are any questions about drainage. You know, we can answer them offline, and we will send all that to you guys. But I want to just kind of wrap up here. Turning back over to Valerie to talk, just kind of give a little more detail on the shore friendly programs. And again, we will follow up with more of that as well when we send kind of the evaluation and, you know, survey information to you and get you some more resources as well too. I definitely have liked the interaction that's been going on in the chat between all of you that are working in this field too. It's been really beneficial, I think, to kind of get you guys communicating together. Val, you ready to take it off? Take it on?
Yeah. Sorry, my computer was just lagging behind for a second. I'm going to go through these pretty quick just because we're kind of short on time. But so far, just let you know, the Shore Friendly, once again, it is a 100% non-regulatory voluntary program where we focus with
Valerie, are you frozen or are you
in the
thinking?
field, like some, huh?
I think you're kind of lagging there. You keep freezing up a little bit.
Oh,
Oh,
okay.
there we go. There we go.
I'm good.
Yep, now you are.
Like my Zoom's not showing like anything's going on like wrong for me. So good to know. Yeah, okay. So we go out in the field with experts who will provide a report for our landowners. We also do workshops like these.
I think we lost Valerie. Oh, there we go. You keep going in and out, Valerie. You want me to kind of take over?
Sure. I don't know what's going on. I think maybe my
Been a
Wi-Fi.
long day of internet, probably.
Yes. Am I
Let's see.
still sharing my screen?
Nope.
Okay, let me try again.
How about do you want me to share mine and you start talking? No, no, there we go. It's actually you that keeps freezing up and losing.
Oh, okay. Well, if it happens one more time, we'll just switch to yours then. Have you guys been able to hear me at least?
In and out. You've been freezing and
Okay.
yeah.
Just start over then. Yeah. So shore friendly, 100% non-regulatory, 100% voluntary. It is a free service to our homeowners, our parcel owners on the shoreline. We offer free technical site visits and reports with experts like geocoastal morphologists and people like John. We also do landowner workshops. We'll do beach walks with neighbors. We do shore projects. So we help design vegetation designs and currently Island County is looking for a partner within the county to even help with planting native vegetation for our residents because most of our residents in the county are retirees. So they might not physically be up for the task of putting in a whole bunch of plants. So we're trying to find a partner to help with that barrier. But more than anything, I think one of the really big perks about Shore Friendly is that we do cost sharing. So we do provide mini grants, which is based on the activity that homeowners would like to pursue. So what happens during a site visit? Our site visits typically take about 1 to 2 hours long. Once again, they are with an expert in the field for that technical report. For Island County, we partner with the Whidbey Conservation District in Herrera. Other counties might use like the Snohomish Conservation District, Blue Coast. I know Herrera is pretty prolific through the area, so they might be one as well. But yeah, it's just a personalized visit. So essentially all this information we've talked about today condensed into what is specifically needed for these shoreline owners. Okay, and then just to kind of talk about mini grants. So things that are eligible for mini grants are essentially the consulting services. We're trying to get permitting fees, project implementation, project design such as vegetation design. And while we can't pay for everything, we do try to subsidize the cost with mini grants that will range from about $500 to $5,000. And yeah, that was I try to run through that real quick because I know we're short on time, but if anyone has any questions.
No, that was great. And just if I can just touch, jump in here too. So our shore friendly program for the Northwest Straits Foundation, we partner really closely with Island County. But we cover, we've got a partner over in the San Juans, Friends of the San Juans, that manages our shore friendly activities over there. So then we also operate in Clallam, Jefferson, Whatcom, Skagit, and Snohomish. And we've got plenty of materials available. We've got videos that we can have you share with your landowners. But again, I think as we started off the workshop today, and Valerie touched on, is that we look at you as contractors, as influencers of our landowners. And so if you can direct them back to us before they make decisions that maybe are not in the best interests of them as property owners as well, our primary focus, of course, is habitat and species. We can help reconnect them with professionals like you, go in the opposite direction. And provide them with services to offset some of those costs that they may feel intimidated by spending. And also, again, we're just trying to change their perceptions and perspective on how they interact with their shorelines. Understanding that everything is connected and every action that they take has an impact. So we're hoping to move those impacts to more to beneficial and less the detrimental. If anybody has anything else, Valerie, you want to add anything else to close us out? But this has been great. It's been a long day, and we appreciate everybody's patience and your interaction with us. And yeah, we'll send more details out, along with, again, we'll send out all this information about the upcoming WIDB workshop and upcoming dates for other ones for those of, again, your colleagues that may not have been able to attend today.
Yeah, I don't think I have anything else to say other than just thank you all so much for attending.
All right. Well, with that, I guess we will let you go. Enjoy your cold and hopefully sunny weekend. Unless, John, did you have anything else you wanted to wrap up on, or you're probably sick of talking at this point? I think that's probably it. All right. Well, again, take care and we'll be in touch.